Much, much better. Thank you, Rain. Much, much better. I came to a WeWork again today, and yeah, it's remarkable.
Ryan, can I just ask a question about the week 12?
Sure. I'm trying to remember what week is week 12 a week I taught, or is that a previous week? I'm so bad with which ones are which.
It's the New York bestseller thingy.
Oh, yes, yes.
Okay. So I just had a question. So I was looking at the example. Will we have to do like all of those, or could we like pick like a select few genres that we would want to be on there?
Yeah, so generally what I try to push people towards is you need to get data from the server, you need to show it on the page. And that could be as simple as just like the bare minimum is just like the raw data, just like put it on the page.
Okay.
Um, and you can get as complicated as you want. Like, I mean, we saw before with Doug, he had a whole thing where he had like a way you could like select your category. With me, I just like put all the categories on there. The endpoint we're going to use gives you back sort of like all the categories in just like one big blob of data.
Okay.
So it ends up being that actually the easiest thing is just like to show them all. Um, but it's sort of like I'm I guess I can't really give you an answer because it depends on kind of how far you want to take the exercise.
Okay. All right. Thank you.
Yeah. So Rain, you said I'm using ArcGIS for my capstone. Ryan, do you have any experience with that? I don't have any experience with ArcGIS. I know I've heard about it. It's like a mapping tool, right? I think. Yeah, okay. Um, so I guess I don't have any direct experience, but if they have documentation, I bet it shouldn't be that hard to kind of work through it. So I guess I don't know if I can give you like any direct like pointers, but if it's something where like you're having trouble with it, feel free to set up a one-on-one. We can take a look. Mel, do you have any experience with ArcGIS?
Yeah, I was just typing back in the chat. I've actually
Nice.
I visualized about 2 or 3 maps with ArcGIS just with our city of Syracuse data set. Yeah, that's my experience with ArcGIS for now. But to your point, Ryan, they do have extensive documentation and it's very good.
Nice. I'll throw out there that if you're doing mapping stuff, I've used this provider called Mapbox before, and they're very excellent. In particular, what they do a really good job of is like map customization. So if you want to do something like you want your map to be like colored in a certain way or with like certain layers, or you want to like put stuff on top of your map or make it like super interactive, they provide a lot of sort of like input to make that easy. They're kind of like one of the most popular mapping services. They're like is it between something like Google Maps and Mapbox. Mapbox is often like the better choice for like a developer perspective, but I guess I don't know how Mapbox compares with ArcGIS, so I can't really speak to that part. Anyway, I think we sort of have a bit of a quorum here, so I think I'm going to try to get started. So before we get started, I have a little announcement to make that Max wanted me to pass along. So Max, for the past few weeks, and it's also kind of me last week, like we've been noticing that a decent number of folks like keep their cameras off. And like I understand that there's like reasons for that, like maybe you got stuff in your background you don't want people to see and all that, but sort of from the teacher perspective, it's kind of hard to teach when like I can't see people's faces. So Max was sort of like proposing something along the lines of if you need to keep your camera off, like send me or Mel a message, just let us know, not a big deal. But otherwise, we'd really like you to have it on. And we're thinking we're going to like institute a policy where if you don't have it on, you don't let us know, you might not get attendance for the class that you're in. Like you may not get attendance if you don't have your camera on and you didn't like let us know that you didn't have it on for a reason. Like really the reason why we're trying to do this is like we've had instances in the past in like older cohorts where people have done things like they have like had their camera off and like not really been like active, just like walked away from the computer, just had it sit there and stuff like that. It's just like really just trying to kind of like maintain accountability and also like to make it easier for instructors. So yeah, and like no problem if like just like really it's just like to prevent like kind of behavior that's like taking advantage of the system here. That's all. So just wanted to call that out. And I think like in general, that's going to kind of be the plan going forward, that a policy is going to apply. So any questions, let me know or let Max know. We'll sort of figure it out, but we're going to give it a shot for a bit here and see how that goes. So getting back to sort of our regularly scheduled programming here. So yesterday I had some internet troubles, but I should be in a better state now for today and hopefully for the rest of the week. But I did ask you to watch a video. And that video was of the lesson that I was going to give, only it was what I gave like last cohort, like 6-8 months ago or so. And it was about promises and fetch. And what it did is it went into a bit more in depth on like why promises exist, what like how that whole interaction's working in the browser. And my hope was it would allow it would be clarifying to some folks and provide like a different sort of explanation as to why how fetch is used in the web browser and how it kind of works. So I guess I'm not really sure necessarily the best avenue I should take from here. One option is I can try to kind of go through what I was going to go through yesterday, but a bit quickly because I do have some stuff I need to cover today and I only got a few days left. So I need to try to fit in what I can in that amount of time. So I can either kind of go through that stuff quickly and we can ask questions, or if folks watched and they just have questions for me now, I'd be more than willing to take those now. Or if that explanation just didn't work at all, we can try something else. So I'm just kind of putting it out there, like, how did the video go yesterday? Any like thoughts, questions?
Can you like go over a little bit of it now, like quickly?
Yeah.
I was confused.
Okay. Yep. Makes sense. Any other just thoughts, perspectives? Just trying to sort of like read the room here, understand like how well it hit. If is Sequota's perspective sort of like emblematic of the room? It's fine if so. I just want to like I need to understand so I can be effective here. Maybe okay. It sounds like then maybe the best thing for me to do is to kind of go through what I was going to do then yesterday, an overview, and then maybe we'll try to do what we can before the break. Then after the break, I'll sort of cover what I was going to try to cover today. Okay. So
Ryan, did you turn the recorder on to record?
yeah, it should be recording. Hey Mel, can you just verify it looks like it's recording? I think it is, but okay, cool. So when I kind of left off yesterday, I was talking about this idea of having like a function you want to run or something you want to run and you want to delay a certain amount of time. And what's tricky about that in JavaScript is what is called a single-threaded programming language. There's just like one line of code that can run at a time. So if you're like going through this here, you're like running this, you're waiting a second, running this, waiting a second, running this. If you're here waiting a second, or just sort of like pause there for a second, that's sort of like locking up the browser. The browser can't do anything else while you're pausing there for that second. And there's other things the browser might be doing in the background. Things like maybe you resize your browser window and like the whole thing has to like relay itself out. Or maybe you click on a button while you're waiting in that second, and like you need to be able to handle like that button click. Or maybe you do something like you like hover over some sort of thing and like does like an animation. These are all things that like the browser has to be able to handle, and it needs to run its own logic to make that work. And if your JavaScript thread is just like stuck in that waiting, then it can't do that. Like it's already doing its one thing. So this idea that I was kind of started presenting yesterday around like how many programming languages they had just this function where it's just like you just wait for like a second, it's just like locked up there for a second, won't work in JavaScript because JavaScript is single-threaded. So we need to like we still need a way to be able to do this. Like this is an important behavior, like being able to wait for a certain amount of time. So the way that this works in JavaScript is a bit different, and it relies on this thing called the event loop. So JavaScript, along with it being single-threaded, it's an event loop-based language. And what that means is once JavaScript is done running your code, once it gets to the end of your file, your one little execution pointer, like the thing that's running your code line by line by line. So in this example, like start on line 1, then sort of like skip over all these comments and go to line 10, 12, and 14. After it gets to the bottom of your file, that execution pointer sort of like goes and like chills out in like a special little spot. And I've been calling that special little spot the holding area, but you can think of it as like whenever the pointer is not doing anything, whenever it's done running all its code, it sort of just sits there. And the reason why it does that is if the pointer's there, it means that the browser can sort of like listen for events that are happening on the page. So if you like resize your browser window and your browser like execution pointer, that like line of code you're running, that's sort of stuck in that holding area spot, then like it can say, oh, you're resizing the browser window. Okay, so I'll like jump over to the browser resizing stuff and handle that. And then when I'm done, jump back to the holding area. And then maybe you click on a button and it's in the holding area. And it's like, oh, okay, so well, you click on the button, it jumps from there into the button click code and then jumps back to the holding area. So this idea of it, like the pointer can either be like running something, going through line by line by line by line, or it can just be like done and like waiting. This is kind of like a neat attribute of JavaScript, is sort of the way the language works. And it means that you can do things where like you are able to work in what are called events. Like I mentioned like the browser resize thing. Like you don't have something in your code where you're like just looping around being like, okay, did the browser resize? No, okay, loop around. Did the browser resize? No, okay, loop around. Like you don't have sort of like these imperative logic statements that are you're like checking to see if things are done, or like periodically checking like, did the button get clicked? No. Okay, did the button get clicked? No. Instead, you just have something where the pointer's waiting somewhere. And then when an event happens, then the pointer just like goes to anything that's listening for that event, goes to any sort of like functions that should run, any sort of things that should handle that event, and it'll run those. So like a great example here is like the button click example. So what you do is you sort of tell the browser, okay, when the click event gets emitted from the button, I want to run this function. And what you sort of do is you just sort of like ahead of time tell the browser like, listen for this event. When this event happens, do this thing. And then because of that, it means that when you click that button, it's going to trigger an event. And then like it's you sort of like that event, then when that happens, if the cursor's in like that holding area, it's going to say, oh, that happened. Okay, let me find all the things that are waiting for that event to happen, and it'll run those functions one by one in sequence. So before I kind of continue, thoughts on the event loop. What do you think about it? Does it make sense? Any questions? Palash, go for it.
Does that mean every time an event listener is added, it goes through this event loop and it makes it asynchronous?
Correct. So the whole idea of like an event loop is by nature asynchronous. Like when the event gets triggered, like and the output happens, like there's time there. Or like when you set up your event, like you're saying like things will happen in the future. Those things that happen in the future, you don't know if they're going to happen like in a second, like in 5 seconds or whatever, but they're going to happen in the future. So you're sort of like setting up this like saying like when this event gets emitted in the future due to the thing happening, then run my code.
What if we add like we attribute one event to say 2 different functions? I think you explained it, but
yeah, you can totally do that. So just like you could add 2 click handlers to a button. I guess, did that answer your question, or did I miss it?
Yeah. I mean,
Okay.
like, will that still be asynchronous, or will those 2 functions like are called in sync with each other?
Yeah. So remember, you got one execution pointer. So what's likely going to happen is if you have 2 functions, let's say you've got like click event handler 1, click event handler 2, and you define click event handler 1 first, then click event handler 2 second. What will probably happen is when you click that button, click event handler 1 will sort of like the first one you defined. So what it'll do is like it says, oh, I got that event. Okay, let me get all the functions that should be called when this event is received. And it will say, oh, there's 2 of them. There's click event handler 1, click event handler 2. So it'll call click event handler 1, sort of run that from beginning to end. Then it will run click event and handler 2 from beginning to end. Importantly, it's not going to run them at the same time. You've only got one execution pointer. So you have to go through like each one individually. And also it kind of brings up the point of like what happens if an event occurs while you're inside of another event, and like that can happen too, where like you're in like a click handler and you click a button like while it's processing that. And that kind of depends on how things are implemented. But typically what will happen is sort of like it'll just sort of like add that to the end of like the events to process. So then like once it's done processing everything, then it will process that next one. But importantly, because you've only got one execution pointer, you can only do one thing at a time.
Right. Sorry, 2 more quick questions.
Yeah.
A promise does not come in this equation until fetch is called upon a URL, right? Or
so yes, importantly though, right now I'm not even talking about promises. I'm just talking about how JavaScript works.
So final question is like, does it matter if the syntax is to add event listener, or can we go in HTML and add an on click? Does that do the same thing? Still makes it
does the exact same thing. There's just 2 ways. Yeah, 2 different ways of doing the same thing. Generally, add event listeners the recommended way. Like the on click thing is kind of old and deprecated, but they both work.
Thank you.
Yep. Okay. Any other questions, folks? Okay. I'm going to keep moving. But I am more than willing to sort of go into this stuff here. Or if you want to sort of set up one-on-one time with me, that works too. Okay, so we've got this idea of an event loop where you have this events that get triggered and then functions that run later once those events are triggered. So like, maybe you're kind of catching where I'm going with this, but one way we could maybe set this up is like, what if we could do a thing where we could say like, add an event listener that will trigger in like a second. So it's like kind of a different way of thinking about the whole idea of delaying. Like the sort of initial delaying logic here, like in sort of the imperative way I talked about with like sleep, is you're just like waiting. But then like the other way, this event loop way is more like you're sort of like setting up the dominoes and then like later on like pushing one domino or something like that. You're sort of like you're saying like in a second run this function, but then you sort of like after you like set that up, you then go down to the holding area and you wait until that event kicks off in a second, then you sort of go back and you start handling that event. It's like a slightly different approach to doing that, where one, you're just like waiting, one, you're like going through this event loop process. In effect, though, both result in the same outcome, where you're able to run code after a delay. It's kind of like I guess this whole event loop idea is what makes JavaScript, I think, tricky for a lot of folks above like a super beginner level, because this event paradigm is what really provides a lot of power to the web browser, but it's not really how your mind works. Like it's not like top to bottom. It's not like reading like a paragraph. There's a lot of sort of like you go through a thing and then you like pause and then you sort of like jump somewhere else. There's a lot of jumping around back and forth. So if it's something that like you're not comfortable with, that's fine. I know this is kind of cliche, but it's one of those things where like you'll get better with it with time as you start to like use it a bit more. But like I think everyone who encounters this for the first time, like their head kind of explodes a bit. So let me change this around. Like before I was sort of showing you with like the sleep function yesterday and like how you might do this in an abstract way. Let me actually write this, how you would do this. So like log a thing out, wait a second, log a thing out, wait a second, log a thing out. And the function that we talked about, or that I mentioned, that you also said that Max had mentioned to you also previously, is this thing called set timeout. And that's what lets you do this whole behavior where you have like an event that you like are waiting for that happens in a second. Like this is set timeout is kind of what orchestrates that behind the scenes. Set timeout is like a built-in function. It's just like console.log or document.getElement by ID. It's sort of just a global thing in the browser. It's in every JavaScript environment, both Node and the browser. So what you would do is something kind of like this. So instead of waiting a second, what I'm going to do is I'm going to write a function. I'm going to call it like run in 1 second. And I'm going to put 2 inside, and I'm going to just get rid of 3 for now. We'll come back to 3 in a second. And I want to run this function. In a second, I want to like call this function. And the way this will work is like I'm saying that in a second, an event will be triggered, and then I'm listening for that event, and that will call the function. Like that's kind of, it's using that event loop logic to make it happen. So the way I do this is I use this function called set timeout. Set timeout takes 2 parameters. The first one is the function you want to call. So in this case, it's run in 1 second. And the second parameter is the number of milliseconds that you want to wait before you call that function. So in this case, I'm going to do 1000. Now, this is like the minimum you need to do to make this work. So if I save this and I go back over to my web browser, DevTools here, and I refresh, what you're going to see is it's going to go 1, and it's going to wait a second, then you're going to see 2. So importantly, it's not going to go like 1, 2 right away. There's going to be a delay there. So reload 1, 2. Do it one more time. 1, 2. So it's like there's a delay. And like I can make this like 5 or something, and now 1, it's gonna wait 5 seconds instead. So there we go, 2. Okay, so cool. That is how you'd approach this like delaying action in JavaScript. But like, let me add this 3 back in, because that's sort of where things like, I'll sort of do this for a couple more. They can log up maybe like 1, 2, 3, 4 or something, like delay 4 times. So to do something like that, I would need to sort of go through this whole thing again. So maybe like after I've logged out 2, maybe like make a function run again in 1 second. Okay, so what did I just do here? Let's sort of walk through this bit by bit. So console.log hello. Okay. Console.log 1. So we see 1 logged out in the console. Then we define a function called run in 1 second. So that's the opening curly brace, that's the close curly brace. We just define this function. And then we call set timeout, and we pass run in 1 second to this set timeout. And we give it a timeout of a second, 1,000 milliseconds. And then after we do that, we go down to the holding area. So like we're done running our code. Like we've like done everything we can. But what we have importantly done also is we've set up this timeout. We've said like in a second, trigger this function, or in a second, send an event, and then set timeout will listen for that event and then trigger the function. So we're down in the holding area, sort of waiting there, doing nothing, just like twiddling our thumbs. And then eventually in a second, the set timeout will realize, oh, okay, this event's been received, and it'll call our function. And once it's called our function, then it will start running bits in here. So it'll log out 2. And the same kind of thing will happen again. So it'll define this function, run again in 1 second. And then after it's defined that function, it'll call another set timeout. So it'll call it set timeout again. But this time, it'll call run again. It'll pass run again in 1 second to it with 1,000. So wait a second, 1,000 milliseconds. And then after that, it returns because it's done processing that event. Like it's done processing the original set timeout event. And because it's done with that, it goes back to the holding area. So it's back down to that holding area. It's waiting. But there's no code to run because it's sort of gone through all that. But it's waiting for like that timeout to occur, that function to get called. And then once that event is received and it's able to process that event, it says, oh, okay, there's a function that needs to be called after 1,000 milliseconds has passed. So it calls that function. It logs out 3. So that's in essence what's going on here. Let me go back over here and reload. And you can sort of watch the 1, 2, 3 come in sequence. 1, 2, 3. Thoughts on this? Any questions? Blush, go for it.
Is there a reason you called one function inside the other?
Yeah, there is. So I put it inside here just because I put it next to where set timeout was defined. In theory, I guess you don't have to. You could stick it kind of wherever. Like you need to find this function somehow or somewhere. So you could put it up here as well.
Okay.
And what I'm going to get to is you can also define it inline. But I found that usually defining the function like explicitly to initially makes it a little easier to follow. So Quota said, is a function like a let because it can be changed in like a const? Ah, okay. I thought you were familiar with this function syntax. Let me update this to use probably the syntax you're used to. Sorry, I didn't realize that. Does something like this look more familiar, Quota? Just want to confirm. Sorry if I made that overly confusing with that function syntax. So I'm defining some functions equal to some variables, and they're const variables. They're not things you can change. Any other thoughts? Any other questions?
I have one.
Yeah.
Can you give a real life example, like on any type of user interface where we would need this pause? And
Yeah.
also, when will we utilize the parenthesis after the function? As you can see, like where you have run again in 1 second, you have those parentheses that aren't being used.
Yeah. So your first question is like, where do you use this? Why is this important? One great example where this is used, let's say you've got some sort of like animation you're doing. So you're doing something where like you're showing a thing, then you're waiting a second, then you're like moving it up and then showing it, and then wait a second, moving it over. This whole idea of like you're doing something interactive where you need to have like forced waits in between a series of actions. Or like another example is maybe you have like a little like hover over menu on like a link, and you hover over that link and you want to like wait a second before you like show the thing. That's a case where you need to like delay in JavaScript before you actually like make the thing visible. In general, this comes up like all over the place where you have like something that occurs and then you want to wait a bit of time before you actually like do the thing that like or perform the action that like you were going to perform when the original thing occurred. That was sufficiently vague where it may have not been helpful, but let me know if you want me to clarify that further. You also mentioned the parentheses though. The parentheses in this case, these are like, this is a function definition. So in here right now, this is a function that takes no arguments. It has no parameters that are in there. But you could pass some parameters in here. You could have like A, B, or any sort of items in here like this. And if when you called this function, you like, this is kind of starting to break my example a bit, but I think it'll kind of get the point across. Like I could call this function with parameters with like 1 and 2, and now A would be equal to 1 and B would be equal to 2 in the context of my function. So that's kind of like where you would utilize like the parentheses, like why those are there. In this case, though, there's not really any parameters we need for this action. Like it's just sort of like we're calling the function, we're just saying like, okay, run now. There's no sort of context we need to give it about how it would run. So there's no real need to pass any parameters in this kind of example. Cool. Any other questions? Just gonna get rid of those arguments. Tara, go for it.
I just have a quick question. And the examples that from the class last year that we were watching from the YouTube video, when you were showing examples with the set timeout, the seconds were set outside of the parentheses of the set timeout. Like what makes this example different from like the set timeout was inside of the function and then like the 1000 was called outside of that function?
Do you mean like
separated?
Like this kind of thing?
Like outside of like the curly braces.
Like
is how it looked on the video last, but I mean it was in parentheses, so I believe about
okay.
But it just wasn't like inside of the parentheses right next to the set timeout.
I will admit, off the top of my head, I am not sure what you're talking about.
Yeah, okay, yeah,
okay.
I just said, sorry.
Okay, yeah, so
doing a good job at explaining that.
No problem. It might just be that like the way this is being enlisted together all together, like oh yeah, okay. I see. Yeah, so I was working my way towards that, but I think that you leapfrogged at our you were asking about where I was going to go next. So let me just go there now, and then I think it'll be helpful for you. So
okay, sorry.
No, that's perfectly fine. So generally, when you end up writing this sort of stuff, you're probably realizing these kind of function names are sort of hard to wrap your head around and are like kind of, they're just like, if you need to do another one of these, you have to make like run again in a second. Like it's just, these names aren't really that helpful. So what I tend to do very often with set timeout is instead of using named functions, I'll just do the function inline. So I'm going to take like this whole bit here, and I'm going to move that inside of here. So I'm going to just move that in there. And then I'm going to take this bit here, I'm going to move it in there. So all I'm doing is I'm like taking what I've defined as a variable above, and I'm just like putting it in line in the function declaration. Or in the function call, not declaration. So something kind of like this. So this probably looks more like what you were seeing yesterday, right?
Yes, yes.
Okay, cool. So in this case, it's like the same kind of thing that I just walked through, but it's potentially a little easier to follow. So you're like, you log out at the beginning here, then you call set timeout. So set timeout, you've got your parentheses there of your function call. Here's your first argument to set timeout, the function you want to call in 1,000 milliseconds. So that's your 1,000 milliseconds, how long you want to wait until it gets called. And then you go down to the holding array and you're sort of stuck there for a second. And then after that second goes by, the event sort of, the event loop system ends up calling your function. And then now you're inside of here. So you log out too, and now you call set timeout again. So you've got your open parenthesis and your closing parenthesis. And then this is the function you want to call in a second, and that's your 1,000 milliseconds to know you need to call it in a second. And then after you do that, you jump down back to your holding area because you're done running this function. So you finish that, you go down here, sort of wait for a second, then you come up to here and you log out 3. And if I save this and go back over here, 1, 2, it'll do the same thing. Cool. Okay. So this sort of style here of working with, I guess I should also like clarify, set timeout is asynchronous. So importantly, like when we call set timeout, the code that needs to run like later isn't being called immediately. Like we're not like returning a thing. It's like we're waiting until later to call it. There's like delay there. Our whole like timeout operation can't happen instantly. And that kind of is like maybe ties back to what I talked about last week with this idea of asynchronous function, a function where the function won't complete running until the future. It has to return immediately. Like you see here, like the return value, like set timeout is returning something, but like this is just isn't an important value. Like what's important, like what this function does is it calls this parameter you pass to it. It like calls a function you give to it. The return value is like not really critical. So because of that, like it follows a very different paradigm to functions you've used so far. Like this function, like there's a function you have to give to the function. Like that's sort of how like that's like what it does. And this whole idea, this asynchronous sort of paradigm here has a name. And they've probably heard me say it a few times, but maybe it's not really connected, or maybe Max has mentioned it too. It's called the callback pattern. And the reason why they call it a callback is like whenever you like take a function and you like invoke it, they call that calling the function. So you have like a function like up here, you have add, you call add, you give it 2 and 3, you're calling this function add. So the idea of a callback is when you have an asynchronous task, because the asynchronous function can't return immediately, like it can't, or sorry, it can return immediately, but it can't like return immediately with a value it calculates later. Like that's just impossible because it can't do that. Instead of returning by like return, like the keyword return, like this kind of returning, the callback pattern, the whole idea is instead of returning like this way, you return by calling a function you pass to your function. So in essence, what's going on here, like what this function does where it returns and what this function does where it calls this function, it's kind of like the same idea conceptually, where this function to like say it's complete, it returns a value with the keyword return. When this function's done, it calls this other function, and like that's sort of how it says it's complete. both functions have a way they can sort of indicate they're done. It's just the asynchronous kind does it a different way with this callback thing. Because there's no way to return a value immediately from the function if the value hasn't been computed yet. Or like in the case of set timeout, if like you don't want to run your code yet. So this callback pattern is incredibly common in JavaScript. You will see it all over the place. And it's just because of this, it is a very easy way to handle to like solve this sort of problem of you having an asynchronous function, especially in a context where you've got a single thread and an event loop. Okay, any thoughts on callbacks?
Good to go for now.
Okay, so one thing I should also mention is set timeout. Like this callback is effectively like you're returning nothing. There's no data being sent like through this callback. But what you'll see very often, a common pattern, is this function here that you pass, like that gets called, will actually take parameters. So you might have something like, in essence, like a return value that is like a parameter of this function. So when your thing here like returns by calling this function, it can actually call this function with a value. And this is sort of like the equivalent of something like that conceptually. Though of course this wouldn't work because set timeout's asynchronous, but like that's sort of how you can get a value sort of like onto the next step in an asynchronous function by like passing it through as a parameter to the callback. Cool. Okay. Any other questions? I'm going to keep going then. So what you're going to notice here, and is that this code, if we sort of continue this pattern, let's say I want to log out like 1, 2, 3, 4, 5, like each delaying a second, which you might be like, Ryan, that's super contrived. Why would you do that many of these asynchronous operations in a row like that? And my answer to you would be like, you'd be surprised how much these stack up in like complex real world applications. It's quite common to do like 5, 10 of these sort of things in a row. Now, timeouts, yeah, you have a point there. Like the timeout case is a little bit contrived, but sort of let's abstract this just to like, I mean, we've talked about timeouts. We've also briefly touched on fetch last week, but like there's many other asynchronous operations. And like just speaking as a whole, like I realize you don't know about many of them yet, but like if there's a lot of these that you might need to perform in an application. And like if you need to do like 5 or 6 of these in a row, and they might be various different types of async things, but you need to do like compute A, and then once A is done, compute B, then once B is done, compute C, and C is done, compute D. If you do all those in order, you're going to get something that looks kind of like this. So I'm going to go 4. And then in here, I'm going to go 5. And what you're going to see, like this code is sort of like going to the right quite quickly. Like it's going down, of course, but like it's getting indented very far over. So like I'm already here at 1, 2, 3, 4, 5, 6, 7, 8, like 8 levels of indentation. And this is with 2 spaces, or I guess, yeah, so I guess like 8 spaces over, but like this is like 4 spaces, that'd be like even more, like 16. Like it can get like you might be like, okay, whatever, like what's the big deal? Well, if you get in the extreme case here, maybe you've got all this in a function that like is indented over, what you're going to find is that like your code goes to the right sometimes faster than it goes down. And that makes it really hard to sort of see what's on your screen. It's like a very like tricky thing to manage at scale in a large application. But again, you're probably just like, okay, Ryan, why do I care about this? Like, whatever, I can deal with that. Like, I'm a developer, I can make it work. And yeah, I mean, it's possible to make it work, but it just kind of sucks. And a lot of sort of innovations in the software sphere often happens not because the existing solution like just doesn't work, but just because like it's annoying and there might be like a better way to do it. And I think like this sort of pattern, this sort of like issue where the code goes to the right very quickly, sometimes more than it goes down, has a name. And it's called callback hell. I brought it up in my thing last or my video from yesterday. And it's like an issue. It's a surmountable issue, but it's an issue. But like it would be great to fix this, because if you didn't have to deal with your code going right so much, it would be like easier to understand or easier to like read. But also like if you think about this too, I guess, like this makes it a bit easier to understand because you've got like the 1, 2, 3, 4 in a row like this. But we walked through this before too, and there was a lot of like, okay, go here, okay, do this, run this, jump down here, run this, run that, jump down here. Like there's a lot of sort of jumping back and forth all over the place. This code is not very linear, which like again, it's like doable to work in this sort of case, but it's just like annoying. It makes it harder to understand what's going on. And like a real cost is when you end up doing this sort of thing, you have all this jumping back and forth. This is the place that bugs can get introduced. If you just don't understand, like if it's hard for you to wrap your head around what's happening, then it makes it harder to like troubleshoot. You're going to forget cases. So like it is more than just like an aesthetic concern. It is like at a certain like scale of software can be a big problem. So I'm kind of leading you all up here because really what would be great is if we just didn't have to do this whole like crazy pattern here. We have like the callbacks all over the place because like the callbacks are required for JavaScript to work, but they end up being kind of tedious for this other reason because there's a lot of jumping around. So it would be really great if there was a solution where it worked in JavaScript, but you didn't have to jump around constantly between lots of things, like jump around from like, okay, you're in your holding area. Okay, this event gets fired. Okay, now this event's going to like kick off another event. This other event's going to like kick off another event. And like sometimes like this event will kick off like 2 events. So then you have to follow both of those paths. And like it would be great if there was just like that was not a class of problem we had to think about. And I'm talking so much about this because I'm going to show you sort of what has been like written to try to solve that problem. And you maybe are catching my drift into where I'm going with this, especially if you watched the video from yesterday. But the answer is promises. This is kind of where they come back into the picture. Really what we want to be able to do is something kind of like this. So something where we could be like, we didn't like, I mean, this obviously isn't going to work, but just like, bear with me for a second here. If we could do something kind of like this, where we've got like our set timeouts, and then we have like our logs in between them. Again, like this isn't going to work, but like, this would be great because this is like, if you had something kind of like this, conceptually, this is very easy to follow. Like log, wait, log, wait, log, like very easy to follow. So how can we kind of make this happen? Well, the way we can make this happen is by trying to find a way to like be able to return again, like really return again. Like the callback thing is great. Like that solves the problem we need to solve with async and being able to like return things. But in essence, we're then like making return values from functions, like actual return values from functions, meaningless in order to like make that callback pattern work. So it would be great if there was like a way we could do that where like, imagine you could almost like return a value that like doesn't exist yet, but might exist in the future. Hint, 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 hint. Yeah, promises. It's kind of what you're going through like last week. If there was a way you could be like, okay, like this value is like a placeholder. It's like a variable, like variable like the math sense. Like later this variable will be filled, but like we're just gonna like pass it around and be like, we're gonna talk about this as like the thing that will exist in the future. This like value that will exist in the future. and we can like use it in a place. We can do a thing with it. But as long as like we can treat it like that, treat that like, when you go back to the metaphor I had last week, we can treat that like box as a thing we can move around. And as long as like as we don't look inside, it doesn't matter if that asynchronous operation is complete. So in other words, like if that set timeout, like if that second has passed, or like if that fetch request sort of went from like the if it like the response came back, or any of these sort of asynchronous operations, like it doesn't matter if that completed. If we've got this box, like it's a box, we don't know if it's done or not. And like we can just say, okay, well, this value, like once this value has come back, we'll do a thing with it. But like until then, we've sort of got this value, like pick it around and we can do stuff with it. So what I'm going to do is I'm going to show you what a API, this is, by the way, this is a little different than what I did yesterday, but I think this might actually be helpful. So I'm going to give it a shot. So I'm going to show you what an API for like set timeout would look like if it used promises instead of callbacks. So keeping in mind, what I'm about to show you, this isn't actually syntax that'll work. Like what I'm going to show you is like a way, like conceptually sort of the difference. And I'm hoping that'll be helpful to see like comparing the callback case and then the promise case side by side. So with this set timeout, imagine instead of passing this callback here, I got rid of that, and I only gave this one parameter. So like I just gave it like the delay. And then this returned a thing like a promise. Also, I'm just going to put up here like, note, this won't actually work, just to make this very clear. This is like an example. So if I just like ran these 3 lines here, something like this, and this were like actually the way you'd use set timeout, you just see 1 and 2 immediately. Like this is what you're doing here is like you're kicking off this async operation, but you're never like, it's like you have the box, but you're never actually like looking in the box to figure out if something is in there, which is fine. Like that's the idea. You have the box, it's like it's this opaque thing, but you need to at some point, like if you're not ever going to look in the box, then like what's the point of ever filling it at all? So what you need to do is you do need to look into it eventually, but you can sort of wait until the future to do that. So a similar API for like a set timeout with a promise would be something like this, where go promise.then. And what this .then thing does, to maybe explain a different way that I brought up last week, is this provides a way you can effectively provide a callback for like this operation. I can specify that callback in like kind of a different way, but in essence, I'm still providing that callback. Like, so that's kind of like, you're not breaking any of the rules of JavaScript here. It's more just like instead of the callback being on the set timeout, it's like the set timeout sort of like communicates with a promise. And then the promise then has the callback attached to it. So like it goes through like the promise is like a middleman, but it's still got a callback at play. Okay, but I'm going to stop talking for a second. Thoughts, questions, concerns? It's really hard, it has me in the situation, to know whether people are doing good or not. So let's do it this way. If things are like, you're like, this is kind of making sense to me, or at least somewhat making sense to you, give me a thumbs up as a reaction. If things are like kind of like, I don't know, give me like an expressionless face, a moderate face. If like things are going bad, give me like a thumbs down or something like that. Okay. I think I'm seeing a lot of, here's what I'll say. I'm not seeing a lot of thumbs down. And I think that's excellent for where we're at right now. I'm seeing a lot of like that. And that's great. So Amberlyn, you said, I guess my question is, are you explaining what not to do because this won't work? So this example, why I guess I brought it up is because I wanted to show you like a comparison side by side of how you like a promise, like a API, and how a callback API would compare. Because it seemed kind of like, although maybe I read the room wrong, that the callback example made more sense than the promise stuff I explained originally. And by originally, I mean like last week. So maybe this was a poor choice of example in hindsight and made things even more confusing.
Can I just add something?
Yeah.
I didn't think it was, I wasn't sure if you were leading us, I guess from watching the video yesterday and watching you explain like the promise, then, but they also had values in them like reject, return, value. So I guess I didn't know where to say I was feeling at the moment because I wasn't sure if you were leading us up to that. So I didn't like want to jump ahead.
Yeah. So, I mean, I'll say it sounds like, although please correct me if I'm wrong, it sounds like you actually have like a decent grasp on this. Because you're using some of the right words, and that's great. This is one of those things where like I'm trying to sort of play a game here between like not going super in depth because we have other stuff we got to cover today, but also trying to be cognizant that like there's still a lot of confusion in the room. So I'm trying to like pick what to cover that I think is going to be most impactful. And I haven't talked about like that whole like new promise syntax, like the resolve and reject thing. Although maybe that would be a good direction to head in here. I don't know. Yeah, I guess. I think that, well, let's maybe it would be helpful for me kind of to continue here is give me the same sort of reaction that you just gave me about sort of the state of things on callbacks in particular. The idea of a callback. Thoughts on that? Does that make sense? Sort of not make sense? So this, or this.
Brian, I just wanted to say excuse me, for me, I kind of just need to go back and like revisit the video after. So that's why I'm saying like in between, because like I get it, but I just need to spend more time with it. So that's why I'm not like fully
Yeah.
like see it more in practice, if that makes sense.
Totally. And I'm gonna keep saying it. I've been saying it. I'm gonna keep saying it again. That like this is one of those things where it's takes just like a lot of being exposed to it for it to make sense. It's the first time I was ever exposed to this, I was very confused. The second time I was very confused. It took me like 4 or 5 times and then like going through a bunch of projects to really get it. And Kenny, you mentioned I like hands-on live examples. The tricky part with this is it's really hard to do an example with this, like without like it's hard to like do an example of like half of it. You kind of got to do like the whole thing for it to make sense. So that's why I'm being a bit coy here, just because this is a really hard thing for like us to sort of go like halfway on. What might be helpful though is to try to jump back to the fetch thing and then have what if we then were to like do an example of everyone making a fetch request? So sort of jumping, like I talked about a bit of the theory here, what's going on behind the scenes, but we can sort of approach it from the other end of, okay, let's actually like try to do it. And then seeing that concretely, and then with the explanation I gave before, that might sort of make it gel a bit better. Okay, let's do that. Let's see how that goes. So I would like everybody to make themselves, open up their code editor, make themselves a HTML document. Something kind of like this here. So I will copy this and bring it into wait, over here. Oh, wait, wrong one. So what I did here is I made a new directory, made an HTML file inside, and I put that inside. And I made a script tag. And I just stuck a console.log in there. So do this, go through this locally, get this all set up locally, give me a thumbs up once you got that good. I'm guessing that generally this should be pretty straightforward for folks. If not, let me know, but once you get that set up, you should see something kind of like this. Yeah, so Rain mentioned, hey Ryan, do you ever use live share? I tried to once and could not get it set up properly. Let me see if I can do it again. But like I will be honest, I don't use VS Code day to day. I'm not super familiar with it, and that kind of puts me in a bit of a disadvantage here. So let me while your folks are getting this set up, let me see if I can take a peek and enable it. But yeah, I think this. Okay, I gotta sign in with my thing here.
Also, do you want this file to be called anything, like to save it, or are we just playing around?
Just playing around, doesn't matter what it's called.
Okay. Did anyone else VS Code update?
Okay, I think I might have gotten this thing to work. I sent the link. Give that a shot. I will be shocked if this works on the first try, but it might. Oh, do I have to like accept everybody one by one? Oh, that's annoying.
I'm sorry, Ryan.
No, it's fine. It's fine. It's more just I'm not complaining towards you at all. I think this is actually really great. It's more just I'm not used to this tool, which is fine. Okay, cool. That seems to have worked. So can you both can see like, or everyone can see that both files I've got open, like the JavaScript and the HTML, right? It looks like that. Okay, excellent. Isn't it great when like technology actually works? I digress. Okay. Cool. So I've got this example here, got my JavaScript, got my HTML. So I'm going to make a request with fetch. So what I'm going to do is I'm going to start by calling my fetch function. And we talked about this yesterday at the very beginning of class, but as a review, the fetch function takes two parameters. The first parameter is a URL I'll make a request to. So I'm going to do http://careersincode.xyz/fruit. Good old fruit. And the second parameter that you pass to fetch is an object. This is optional, but I'm going to specify some parameters. And what I'm going to specify is a method of get. Something like that. Okay. Also, that's, I think, indented. Is that indented? Oh, no, that's just sort of how it works. Oh, interesting. Okay. So I right now am I'm kicking off an asynchronous action. I'm calling fetch, and what it's doing behind the scenes is starting a request. But I'm not doing anything. Like, there's no way that I can handle the result of that request right now. I'm kicking it off, and then I'm kind of just ignoring it. I need to change that. I want to do something once the request comes back. Because in order, if you don't do anything when the request comes back, why'd you even make the request in the first place? The whole idea is you want the data in the response. So I'm going to stick the return value of this fetch functions in this variable called promise. Okay. I'm also just going to log it out. So I would like if you all could replicate this on your end. What you should see is something like this. So hello, promise pending.
Ryan, you may have to click on that thumbtack so other people's names won't show. I could be wrong.
This?
Or so yeah, maybe I'm wrong.
What do you mean other people's names don't show?
Yeah, do you see that? Or am I just
yeah,
seeing...
the people's names in the colored boxes?
Yeah.
Okay. Maybe this?
Well, forget I even mentioned it. I thought I was helping. Sorry.
No problem. It's a good point. I was kind of wondering how I get rid of those too. I just don't know what I'm doing. Yeah, okay. I don't know if I can do anything about it. Okay. Give me a thumbs up if you've been able to get this far. Okay. If anyone wants me to wait a little bit longer, let me know, but otherwise I'm gonna keep moving forward here. Okay.
Ryan,
Yeah.
so mine, when I'm on my live feed, it is only showing the code itself. I'm not seeing the fetch example.
The code itself.
Yeah, so everything that's in the JavaScript the fetch example.js is showing up instead of the fetch example.
Oh, like you're seeing over here, your job.
Yeah.
Okay, make
Mhm.
sure you have your HTML file. That's what you've got that you're accessing. So like if it's index.html, make sure that's up here. If you have something like this up here, you're going to see your JavaScript. So you need to make sure you're viewing your HTML file if you're going to be running the web page.
Okay. Okay, I think I can figure it out.
Okay, if you want to share your screen, let me know. I can take a look, but I'm pretty sure that's all it is.
Okay, thank you.
Yep. Okay. So what have we done here? Well, I'm going to do one more thing. I'm just going to add a little like holding area thing down here just to sort of make that analogy, bring that back. But just some comments shouldn't really change what's actually happening in the code. Okay. So I start on line 1. Log out hello. See hello there. Okay. Skip line 2, the those are empty. So get to line 4. So on line 4, I run this fetch function. What fetch does is fetch kicks off an HTTP request. So what it'll do is it'll read the URL, read the parameters I've given it. And it's an asynchronous function. So what that means is it will make a connection to the server. So it'll look at the URL, be like, okay, where do I need to go on the internet? It'll go through the whole postal service system metaphor, and we'll find that other remote server. And then once it has, it will connect to that server and it'll start sending data over. What's going to happen is when it does that, like it's going to start doing that, but that's going to happen outside of the context of JavaScript. That's going to happen sort of in a totally different spot. So and because that's happening like in a totally different spot, in a totally different thread, it's like not blocking the main JavaScript thread. It's going on somewhere else. And because it's going on somewhere else, after you run this function, like it kicks that off, like it's just going to kind of keep going. And it's going to keep going through all its lines. It's going to get down to that holding area and it's going to wait. Now, I skipped over the promise bits here. But in essence, like there's a return value from this function. I'm storing that into a variable and I'm printing out the variable. But like putting that aside for a second, like what is actually going on with this fetch call is like it is calling a function and it is starting an async action, and that's it. There's sort of like that. That's sort of the extent of what it is doing. The promise bit is important to like get the value at the end of the asynchronous action. That's sort of the way like you would that's sort of the way that the fetch function can inform you that the response has come back, because again, that request is happening sort of in another context and something else not running in that JavaScript thread, because you can't block that JavaScript thread. If that JavaScript thread is being blocked, if you've got like a thing occurring in that thread, then it's going to make your browser unresponsive, and that wouldn't be good. Okay. So now that we have this example, it looks like in general, folks have had success with that. We're going to print out the response we get back from the server. But importantly, like, this isn't the response. Like that's not what it is. That's the promise. But I guess more accurately, you could think of this as like the future response. Like this will be the response in the future. Right now, it's just nothing. It's sort of like it's like an empty value. But once the response comes back, then it will be a response. Like it'll be it'll be like contain a status code and contain a body, like all that sort of stuff that you're used to. So I just changed the name of this variable. Feel free to do that in your code too if it's going to make it easier for you. But after I have done that here, I'm going to go back over to my code. And so like right here, I'm printing out the promise right here on line 8. After I printed it out though, I'm going to like print it out again, like later, sort of like I've done everything. This is like many seconds later after the page is loaded. I'm doing it in my development console here. I'm just going to type console.log future response. And if you didn't change the name of your variable, I change it to maybe disambiguate that promise term to try to go a different direction here. But if you just call the promise, you'd be logging out the promise. But either way, I'm logging about that value. You see, now that promise is filled, like it has data that came back. That asynchronous action is complete. Kulash, go for it.
So how did that work out? Does that mean like if we console log it twice, it's gonna return a response?
Let's give it a shot. So something like this.
Yeah, because is that what's happening in the console?
So I guess when let me do that there. So when I run this, it logs out pending.
Mhm.
And then all I'm doing after that is I'm logging it out again. And I think the important thing I'm trying to draw attention to is that what's printed here and what's printed here, these are different things. Even though I'm printing out like the same value, I'm printing them out at different times.
Mhm.
This one I'm printing out right after I start the request, right after I start the fetch. This one I'm printing out many seconds later. And the sort of like that temporal component, that time piece is key. Because if I print like, if I did something like what you suggested here, I just print this out twice in a row, I'm just going to get pending twice.
Gotcha. If between the two console logs, if we add like a set timeout of say 5
Yeah.
seconds,
That's what I was just going to do here. So if I stick like a set timeout here, kind of what we just talked about. So it's going to wait 5 seconds. And what you'll see is now it'll be fulfilled. So that's kind of the key here, where like what's actually going on, you can think of it sort of like a race. The request is sort of like you kicked off the request and the server is going to come back with a response. And that's like one thing that's racing. And the other thing that's racing is like your set timeout 5 seconds. So it just so happens that my server is quick and it's going to come back, and like it's going to come back in less than 5 seconds. So like because of that, like this log here is always going to log out after the response comes back because my server is fast. But like if I made this delay really small, like maybe like say like 1 millisecond, like really small. Actually, I mean it's going to be kind of hard to see, but I guess you have to take my word for it. There is a bit of a delay there. But like if I reload it there, it's still going to be pending. And I bet like even if I did a thing like maybe like 50 milliseconds, I probably would. Oh, that's no, like 10. No, yeah, like 1. My server's really fast. So like there's a delay there. It's very brief, but like that's a situation where like you're logging it out and then you're logging out again before the response comes back. So the key part is here, like that value is going to change over time. And if you want to get the response out of there, you have to like wait until it is in the correct state. Wait until that response comes back from the server before you can pull the data out of it. If you try to do it before then, it's still going to be like not fully set up. It's still going to be like in the like initial state.
That makes sense. Thank you.
Cool.
Can you let me into the live share, please?
Oh,
No, I'm not getting there.
no, I don't see your thing.
It's okay. I'll come back. No problem. Thank you.
Okay.
Ryan,
Yeah.
so I'm trying to type out what you're doing. I'm trying not to copy. And I fixed what was wrong in Prettier, but every time I go to go live with it, I'm having an error.
Let's share your screen. Let's take a look.
Okay.
Also, real quick, if folks are trying this out, keep in mind that set timeout value, that 1, that's like one situation, then like 5 seconds, that's kind of the other. So like I was just sort of switching that back and forth to sort of do that demo before. So if you're like want to see the value, you need to make that 500 or 5,000, not 1, but like actually see the response value.
So I haven't done the set timeout yet because I wanted to at least get the promise pending like you showed us. So when I go live, hold on a second, I'm getting this. So let me go back. Let me move this actually. There we go. Something has to be wrong, obviously.
In your web browser, go back over. I think you need to click on where it says fetch example.html. You got to load your HTML file.
Okay.
Yeah, there we go. So if you open up your JavaScript console, I bet
Hold on a second.
if you right click and go to inspect element or inspect, and then go to console at the top. Or go down there. Yeah, either of those work. Yeah, there we go. And if you want to have it say pending, just hit reload and it'll show a little nicer.
Okay.
Yeah, there we go.
Did I do something wrong to where I had to open up the HTML? I guess what I'm asking.
Yeah, so I'm guessing most of the time, and this is probably on me here, most of the time when you've been working with Max, he's made your HTML file just index.html.
Yeah.
And if it's index.html, then that's what's going to load by default. So I didn't call it that, mostly because I just wasn't really thinking and probably should have called it index. So because of that, you have to specify it specifically. Like you've got to sort of click on it, tell it to navigate to that file directly. One other thing I just want to quickly call out though, your URL looked like you had careers in code.xyz with 2 Ds. So you might want to correct that as well. Just like careers in code with 1 D for in code. Cool. Okay. Oh, perfect. I think you should be in now, Palash. Okay. I'm gonna switch this back to be 5,000. Yeah.
My bad. Also, it wasn't, I was going through and it wasn't the same thing that she was experiencing, but I did get the same error.
Okay, share your screen. Let's take a look.
All right.
Yeah, so if you click fetch example.html there, not the first one, the second file. Ah, yeah, okay. So go back over to your code. Let's take a look. Ah, yeah, so you see on line 3, you've got const promise equals fetch, and then on line 7, you've got console.log future response. So I think you either want to update promise on line 3 to be future response, or you want to update line 7 and 9 to log out promise. You sort of have to pick one. So like you're trying to log out a variable that doesn't exist right now because you're defining a variable called promise on line 3. Does that make sense? Or do you want me to go a bit more in depth there? Oh, I think you might be muted.
Yeah, when you first console logged it out, I just never changed it from the first example. So that was just me not paying attention.
Yeah, no problem. So if you update line 3 to be future response, I think it'll work fine for you. Keep in mind though, what you have right now, you got set timeout with 1, so you should see promise pending twice. And if you make that one like 5,000, you should see promise pending, promise fulfilled. So give both of those a shot. Palash, go for it.
So callback functions usually are used to deal with asynchronous events. Is that why you have used that console log, this console log inside the set timeout as a callback function, or will that also work sort of linearly?
So
See what I mean, though?
I think I think so. So in this case, because the set timeout is like relatively straightforward to follow and there's not like a series of them, it kind of reads pretty linearly. But like, so in this case, like that callback hell thing I was pointing to earlier doesn't really apply as much because it's just like one level. But if we had like 5 levels of set timeouts, then you're sort of like bouncing back and forth a lot more. But like in practice though, like if you were to actually like follow through what the code execution pointer is doing, like it sort of goes through, it gets a set timeout, it like schedules the function to run in the future, then goes back down to the bottom and jumps back up again. So there is a lot of bouncing back and forth, but it just turns out that like, because you don't have anything after the set timeout, and because like your set timeout's pretty straightforward, like if you follow it linearly, it still does the same thing, even though it's actually not what's going on.
Gotcha. Thanks.
Cool. Cool. Okay. So what we have here, I guess in general, have folks been able to get this to work? This sort of see like the pending state and the fulfilled state in a row with the set timeout. Okay. I'm seeing thumbs up, I'm seeing head shaking. If it's not good for you, please speak up, please let me know. But I think otherwise we'll keep on going here. So this like works, but the tricky part here is like this delay you saw is like something where it's kind of fiddly. Like if you set it too low, you're sort of like you're gonna like look in the promise box before the response comes back. If you set it too high, you're just kind of like waiting for no reason afterwards. You're sort of making your operation like slower. You're sort of just like waiting for extra time. Really what you want to be able to do is you want a way where you can like wait just enough time. Oh, that's weird. Wait just enough time where like once this function is called, this will be like filled. You sort of want to like run this function once the response comes back. You don't want to run it like before or after. You want to run it like when the response comes back. And that is what, so I'm going to take this, I'm going to copy this. I'm going to comment that out, and I'm going to sort of write a new version of these lines below it. So I'm going to replace set timeout here with promise.then. I'm going to get rid of the second parameter, lowercase p, or I guess future response. Future response. Yeah, there we go. Okay. So what I did here is I changed the set timeout to be future response.then. Think of this future response.then is the same thing as set timeout, only it's going to wait just enough time for this future response to have a value inside of it. So in other words, if you run this now, if I go over here and I run it, you'll see that I'm always going to get pending fulfilled. And like, I can't ever get pending because inside of the .then, by the time that runs, like that runs like immediately after the promise gets fulfilled immediately after the response comes back from the server. So it tends to be with promises, this is sort of how you end up handling it, where instead of like delaying with like a thing like set timeout, you instead like tell the promise, okay, once the responses come back, then call my code and let me do whatever I want, like log out future response. Give this a shot on your end. See if you can get the pending fulfilled in a row like that. Give that a shot. Okay. Anyone having trouble getting this to work?
I'm not gonna lie, I'm waiting for your I guess what's the word? I'm waiting for you to show us just to make sure I'm doing it right.
Yeah, fair enough.
You're waiting for your callback. I think I'm using the right word.
Yeah, great way to think about it. You waiting for me to be done as an asynchronous operation. I haven't completed yet, or haven't started going through it yet. So let me walk through here step by step what's going on. So we start at the beginning here, this first line. Well, I'll get hello, cool. Get to the second line, call fetch. So fetch returns this promise thing, and I'm going to store this promise thing into future response. So this is like a container that later on will have within it a response, but right now it's empty. That being said, though, fetch is going to, in the background, kick off the request. It's going to start reaching out, start sending data over to the server. But because it's an action, it's going to take a while. JavaScript's sort of going to run in the background. It's going to keep on going, keep doing its thing. So what's going to happen is it's going to log out future response. But right now, this is empty. It's like the response hasn't come back yet. These sort of things are happening at the same time. Like the request response thing's going on, and while it's going on, JavaScript's running. So we're on line 8. It hasn't finished up, so it's just going to be like, okay, well, we're not done with our response yet, and it's going to print promise pending. Then after that, we're going to jump down to here, line 12. On line 12, what we're going to do is we're going to run this .then thing on future response. And what this is going to do is this is going to take this function and tell the promise that once a value shows up inside of it, to call this function, in effect, like once the response comes back from the server. And then it's going to go down to this holding area. It's just going to stay down there, just going to wait there, just going to sort of chill down there. But while this is happening, the request response is still going on, like still sending data, but like all the code in the browser that it can run is run. It's just sort of like it's done. It's waiting for like its next thing to do. And eventually, after maybe like a couple hundred milliseconds or something, that response will come back from the server and the client will receive it. And once the client receives that response back, remember, this is all happening outside of the JavaScript context. This is like its own separate thing on the side. Once that comes back, at that point, it sends an event. It says the response has come back. And once that's come back, the promise says, oh, okay, are there any functions that wanted to get called as a callback once that response came back? And it turns out there was. So what it does is it jumps to here. And importantly now, because that response came back, that future response value, that's filled, it's got data in it. So it logs this out, and then that's all it needs to do in this function. So it jumps back down to the holding area and just kind of stays there for kind of the rest of the time, like still kind of in the holding area here right now. So what you get here then is this log here, which is happening right here, happening right after the request starts. And then this log here happens after the response has come back because it's inside of the function being passed to .then. Thoughts on that? Any questions? Okay. So I guess, can I get like a thumbs up, maybe a middle or a thumbs down based off of that sort of what we went through there? Yes. Oh, looks like someone got rid of my my code there by accident. I gave everyone read-write access to it, which maybe was a mistake. I don't know what I'm doing with this live share thing. But I guess I don't want to keep moving on here if there's something I can clarify. Yeah, so Rain says, picking up what you're putting down about then. I just need to retain it. Yeah, makes sense. I think thinking about this like a set timeout that has the perfect time to match with the length of the response, like the request response coming back, that might be like a good way to think about it. If or a different way to think about it, rather. So there's one last bit here that I haven't mentioned that is kind of important with .then. Remember how I talked about the set timeout, this idea where like if you with a callback, if you want to like return something, the way you tend to do that is you like pass it as a parameter to the function. So like the call, like if the callback's going to run, if you're going to get the call back to you, if that runs and you want to like return a thing, the way you do that is you like when someone calls back to you, they specify a parameter in that function. So we have like our response here. But importantly, calling this feature response isn't quite right. I'm going to rename this back to promise again. Because I think that in fact, like this isn't the response. It's sort of like the container that wraps the response. So like if I want to get the response, I've got to sort of like go inside the container and get it. And the reason why, like that seems maybe like a small semantic difference, but it's important because there actually is no like way with a promise. There's sort of like nothing I can call on it that's like get the value inside. There's like no way to like query it imperatively, like poke it and be like, give me the thing inside. It's kind of like a little weird that you can't do that, but there isn't really a way to do it. You can do it like in the console here, you can like look around here, but there's like nothing, like if I have this value in JavaScript, there's no way I can like get this response thing inside by just like calling a function or a method on this promise. There just doesn't exist. Like there's just not a thing I can do. So you might be like, well, how do I get the value inside? Because that's like the whole point of this. Like I've got this value here that's being printed out. How do I get what's inside? And the way you do that is it turns out this dot then callback here has a parameter. And this parameter is actually future response, or in this case, more realistically, response. Like now this is like actually the data, the response data. So what I'm gonna do here is I'm gonna have two logs here. I'm gonna log out the promise, and I'm gonna log out the response. Something like this. So importantly, actually, I guess I should say, should continue this pattern here of not modifying my previous code. So I'm gonna do this. Okay, so that's what we had before. So I'm gonna comment that out. And then below that, I'm gonna put the new thing here. So all I did here is I changed future response to be promise again. So just rename that variable. And that's just because I think it's a bit it's going to make it more confusing if I continue to call it future response. But now I'm logging out the promise, but then also the response. So like the response being like the parameter passed to dot then. So if I save this, come back over here, what you're going to see is a bit more. Let me walk you through this. Console.log hello, that should be pretty straightforward. Okay, call fetch. That kicks off the request sort of in the background thread, going on in the background. Makes a connection, occurs in code that XYZ, goes over there, starts sending data over, doing all that in the background. And then fetch returns this like container, this place where the response data will go in the future as this promise value here. Okay. And keep on going. Importantly, our request is going on in the background. We're going bit by bit through our JavaScript, but these things are sort of happening independently. So we log out our promise. And at this point, like the request is still happening. The response hasn't happened yet. It's still going on in the background. So like we don't have any, like there's no data in that promise value yet. So we just get promise pending. Okay. Keep on going here. So get that here, promise.then. So what this is going to do is it's going to tell the promise, once a value shows up in this promise, call this function. So we've sort of set that up, registered that for the future. Eventually, when something shows up in that promise value, this function will get called. And then we go down to that holding area. We sort of stick down there. We're waiting down there, kind of waiting for something to happen. But importantly, our request response thing's still going on separately in like the separate sort of context, still going back and forth. Eventually, we get our response data back. And then once our response data comes back, then fetch will emit an event. It'll say, our response data came back. And then once that event comes back, the promise will be like, oh, okay, the response data came back. I'm going to put that data inside of myself, inside of that container, and I'm going to call any function that has to be called once I was filled. In this case, and that's what we do with .then. Like that's what .then is doing. It's saying, call this function once data shows up in the promise. So what it'll do is, because that event was received, it'll call this function. And the little layer that's new, sort of from the last little time we went through this, is response is a parameter that's passed to that function. So before, we just had this. But I'm going to add this. So I'm going to log out the parameter passed to the .then function. And what this is the value inside of that container. It's the thing inside that we couldn't access like by querying promise directly. The only way you can get access to that value is by getting a callback, registering a callback that gets called once something goes in. So you can't be like, you can't ask it like, what value is inside of you right now? The only thing you can do is you can say, when a value gets put inside of you, let me know. It's sort of like flipping it around. Like instead of like you asking it, it's telling you. And that's kind of the idea that's going on with the callback function here, this function that's get called by the promise. So importantly, if we take a look at this promise result thing, that matches this. These are the same thing. So we're like peeking inside of the promise here. This is the thing that is inside of the promise. So that is like promises. Like that's sort of how it's working. That's how it's working with fetch. Thoughts on that? Again, really the new layer is this response value here that's being passed into the promise callback as a parameter. Give it a shot on your end as well. You should see something that looks kind of like this. So pending, promise, response. So Kenny, you asked, is there a good resource somewhere to read up on all the documentation? Yeah, I'll send over MDN's article on promises. It's pretty good. I'll see if I can find anything else as well. Oh, nice. Mel's an excellent TA. I can also dig through and see if I can find any other like good blog posts or anything that sort of go through this in a different way. Like, I keep saying it, I'm going to say it again. It's one of those things where like, you really have to hear it like 5 or 6 times, maybe from like different perspectives, different approaches, until it eventually kind of clicks. Like, it's something that when I originally learned this the first time, it took me many iterations to kind of get my head around it. It's like not straightforward. Corwins, you say you're getting an error. What kind of error are you getting?
Wait, let me see what you got again before. Yeah. Yeah, that's what I got. But then it told me that my end promise was not defined for some reason.
Let's take a look at what you're seeing. Yeah. Yeah. Go back over to your code. Okay, so I think
maybe I just can't spell. I think that's what's going on too.
Yeah, so you need to fix the spelling of response on line 17. That's for sure. But one other thing, on line 15, you've got promise.then promise in parentheses. You want to make that response. So not the first promise word, the second.
The second one is response.
Yeah. So importantly, promise in this case is like the container, and response is like the thing in the container.
Lowercase or
lowercase.
Okay.
Yeah, and you got to fix your spelling on line 17.
Oh.
Once you do that, I think it should work.
Yeah, dude. I just can't spell today.
Yeah, no problem. Spelling's challenging for me too, usually. Cool. We were supposed to take our break like 15 minutes ago, but I wanted to kind of get through that. If you got any other questions, like let me know, let's go through them. But otherwise, I'd say let's take our break now. I have a whole thing I need to start talking about today about headers in order to kind of keep the pace of the class, given we only have a few days left. So I'm probably going to go through that for the second half of class. So again, like I'd say that fetch is one of those, or sorry, promises are one of those things where it's going to be confusing for a while, and you're kind of going to be going through the motions a bit, just kind of like typing it out without fully understanding it for a bit. And I think that it's one of those things where, like, especially with the New York Times exercise this weekend and sort of the further use we're going to be doing over and over with it, I think it's going to be helpful, but also like it's one of those things where I think over like the next like many months of using it in careers and code in web applications, you'll just get more comfortable with it. So I know it's like not a great answer, but it's still like it's just a tricky thing. It's just a tricky thing. So yeah. Okay. Let's take our break. I think let's try to come back at like be like 7:40. Yeah. Yeah, 7:40. Let's do that. So see you then. And then we'll start talking about headers, which is exciting. That's, by the way, much easier than promises. So that will be good. See you at 7:40. Okay, folks, I think we're gonna start getting started again here. So in looking through my slides, there's actually one other thing I wanted to cover on the fetch stuff. It's sort of ancillary, but it's sort of an important thing to know about. And that is there's some ways you can actually see the request going on in a web browser with a part of the Chrome Dev Tools. So this is just more of like a, hey, did you know you can do this sort of thing? It's kind of a neat little trick and is often really helpful for troubleshooting problems that are going on with requests. So I am going to share my screen here. Okay. So this is a slide here, Developer Tools Network Panel. So if I go back over to our example before, our example is making a request. Like it's going into the server, setting a request, coming back as a response. And we log stuff out here, but like importantly, there's another way we can actually take a look at the data that's being sent. And that is across the top here of the developer tools. There's a number of these different panes. So you've probably used Elements before, you've used Console before, but I'm going to show you a new one. And the new one is the network pane. So I'm going to a little bigger, just so easier to see here. So importantly, so what this pane does, this section of DevTools, is it will print out every request the web page makes. So I'm gonna have this little like clear button here, this circle with the slash. This will get rid of all the data in the panel, and I'm gonna reload the page. So what happened there is, as I reloaded it, you probably saw a bunch of lines came in there, sort of like top to bottom, at like one. So what happened there is we're seeing every request that this page makes. So importantly, the first request is the URL. It's making a request to this. And what's coming back is the HTML for the page. Excellent. Okay. Now, in the HTML for the page is a script tag, and the script has an src of fetchExample.js. So the next request here is it's making a request to get that JavaScript file. And that's like the request URL, it's the request method. These are our request headers down here. Sort of we have like all the bits of every request responsive page is making embedded here in this panel. Go over to preview here, take a look at the response body. So we've got our JavaScript in here. Excellent. This install hook thing is a script that gets injected by the live server thing to make the live reload work. Sort of stuck down here at the bottom. Not all that important for this, but like that's why that's there. But then like this next line here, this is the request we're making with fetch. So this here in our JavaScript code is kicking off a request to there. And you can see here, like we got our URL, we got our method, we got our status code, all the sort of bits you'd expect. And you see the response, apples, oranges, bananas, it's all outlined there. So what's cool is you can make whatever requests you want. And you can take a look in the browser's network panel, and you can sort of see the requests that are occurring. You can sort of like spy on what the browser's doing. This is often really helpful when you're like going to a web application, you're like, how does this work? Or you're making a request in your code and you want to see, okay, cool. So I'm telling it to make this request. What's actually happening? What URL is it actually making a request to? What method is it actually using? What headers is it actually including? What's the body? All that sort of stuff. So why I'm bringing this up is this is a tool that is a really helpful debugging tool. And it's something that as you start to write code in a browser that's making requests with fetch, being able to go into this tool and be like, what requests is this web browser actually making is often really, really helpful. There's one more cool little thing you can do here too. And this kind of gets back to why I was brought up curl at all for this section here of careers in code. And that is that just like Postman can import and export curls, it actually turns out your web browser can export curls as well. So if I go on any of these requests here, say this first one here, this HTML, and I right click on it and I go copy as curl. And I click that. And I go over to like a terminal here and I paste. You'll see that's a curl command. Curl URL -h, a bunch of headers, all that sort of stuff. And if I hit enter, well, okay, let me copy that one more time. There's some caching stuff at play that's making I don't think it work properly. Cool. Okay. Copy as curl. Try that one more time here. Paste. Yeah, there we go. Then we get back our HTML. So I just copied the curl out of the web browser, pasted it in, and got that out here. And importantly, I can go over like Postman, file, import. I can paste my curl in there, and I can send that. I get back my HTML too. So this is really why I showed you curl, because curl, like, it's an excellent tool for communicating the request a web browser is making. And if you want to like replicate a request a web browser is making, like it's making this fruit request. Let's say I like actually want to make sure it's making the request exactly as I think. Like I wrote my thing with fetch, but I'm like, I'm not sure I know how fetch works right. I want to like verify it's working correctly. I can go to the network pane, go to here, right click on it, go to copy as curl, come over here into Postman, paste, and now I've imported my request exactly as it was made, and I can try it out here. I can look at it, I can be like, oh, okay, these are all the headers that were included. You can see the browser includes a bunch of default headers for the request. It's got all those in there. See like no body, I got the method. You can verify it all worked exactly as you expected. So Tara asked, what did you do the second time you pasted in curl? So what I did, the reason why before it didn't work for me, and I'm assuming what you meant is I pasted it in and it didn't give me a response in the terminal that time. The reason why it didn't work is because the thing that the web browser does, and we're going to talk about this later on in later on the week, hopefully, we have time. I might have to cut it if we run out of time, but I think we're going to talk about it. The thing the web browser does is called caching. And what that means is if you make a request, in particular a GET request, and the response that comes back is like data that you already have locally, the client will be like, oh, wait a second, I've already got that data locally. I don't need to like sort of like reload it again. It can sort of like avoid making requests for data that it already might have. And why this is cool is like, let's say you've got like a really big image on a web page. If you make a request to get that image and get the response back, and then you make a request again, if you know the image hasn't changed, it's just like a static image up there on the internet somewhere, why do you have to get the response back again? Like it's the same. You can just store that data locally and not have to make the request response again. So what I did there, if you, on your refresh button in Chrome, if you right click on it, this is a thing you can, by the way, can only do when DevTools is open. So if you try to do this without DevTools open, it's not going to work. You got to open up Developer Tools. And once it's open, you right click on refresh and go to empty cache and hard reload. What it will do is it'll force the web page to sort of like reload itself without all that cache data involved. And from time to time, you might have to do this if you want to get like the request to work properly. Like the reason why I did it in particular is when I reloaded this. Yeah, so I saw the status code was 304 not modified. This is something else we're going to talk about a little bit later in the week, but this sort of means like, oh, it's using that cached response, using that data that's cached locally. So what I did there was I did this, did the hard reload, and that forced it to come back with a 200 rather than the 304. So it's like a 200 is like, okay, it did the request response. What it got back from the server was like what was expected. So that's what I did there. In practice, so like if you're making like API requests with fetch, this isn't really going to be a problem. Like this is only a problem for things that the web browser is going to cache, which are like the HTML file, image files, things like that. The way that API servers tend to be set up, again, something we're going to talk about later this week, but the way they tend to get set up is like they're not going to do that caching. So like if I just reload this as many times as I want to reload this fruit request is always going to be a 200. It's not going to have that 304 thing. Anyway, If that made sense to you, great. If it didn't, no big deal. This really shouldn't be a problem for the vast majority of requests you'll ever inspect in here. But you asked, so I went into it. Any questions? Any thoughts on that? Okay, cool. That's really all I want to do. I just wanted to expose you to this network panel, and that really the two takeaways are you can see every request a web page makes in here. So if you want to see what a web page is doing, this is a way you can do it, like network wise. And the other thing I wanted to really call attention to is if you right click on any request, you can go copy as curl and get it as a curl, just like you can export it from Postman. You can also export a request from Chrome. So Corwin, you said, I'm not getting the install hook. So guessing you're referring to this request here. That might be something related to like a Chrome extension I've installed. Let me do this. Open up an incognito tab, so there's no extensions running. What if I do that? Yeah, it's not in there. Yeah, so don't worry about that. Looks like that was something related to how my browser was set up. You should just see, really the important thing here is the HTML, your JavaScript, and then there should be that request you made with fetch, that fruit request should show up in here in this list as well. Those are really the three, there we go, right number of fingers. The three things you should see in that list. Cool. And yeah, Mel mentioned Command-Shift-R will also hard reload, I think. Which is pretty good. Oh, yeah, that's a good point. That's a hard reload, not a hard reload without so there's these two options. They do slightly different things. Off the top of my head, I'm trying to remember what's different between them and I forget. I just know this is the one that I always go with. And this is the one that I know always works. This one has like some gotchas sometime. And I forget what it is. And I'm sorry. I didn't review this before this class. I'm not sure off the top of my head. But like again, caching really shouldn't be a problem for API requests. Yeah, so Corwin said favicon ICO. You might see that in the list as well. So that's something where in order to show a little icon up here in the corner, your web browser might try to make a request to /favicon ICO. That's sort of the like index.html is where HTML files by default live. That /favicon.ico is where a browser might try to request to get this little icon. So if you see some requests like that in there, that might be what's going on there. But again, like really the thing to look out for here is your HTML, your JavaScript, your fetch. Like you should see all three of those in there because those are the three things your browser really is doing to make this application work, to be able to show all these logs. Okay, that's really all I wanted to talk about for the developer tools panel. I'll also give you the hint that for the New York Times assignment, this is going to be a helpful tool to sort of like peek around, and we'll get to it sort of later on in the week, but I'm just introducing this because I think it's something that might be helpful for you for that project. So Corwin, you said you were asking because the favicon ICO gave you a 404. Yeah, so the reason it gave you a 404 is because your web browser tried to get that icon, that ICO file, that icon file, and it couldn't find it. So it's probably just showing you the little like globe or default one. That's totally normal. That's going to happen. Like that's just sort of a thing that web browsers will often do. Okay. So we are going to try to blow through headers here kind of quickly. I think that should not be too crazy because this is just like this is going to be more of like me presenting a bunch of information that you might want to review later. But there's not a lot of like, this is just, we're going through a bunch of headers. We're going to sort of talk about a bunch of headers that you might include in requests and responses in your HTTP calls. And I'm going to talk a quick bit about like where each one is used, what's important about each one, and where you might include one in a request or response. So here are the headers that we're going to talk about here. Content type and accept are the first two. Content type is a header that can be included in the request or response, and accept is a header that only goes in the request. Authorization, that's purely a request header. Location is purely a response header. Post is purely a request header. Custom headers, which start with X dash, those can be in the request or response. And then lastly, access control header, which can be in request or response. Okay, so the first custom header we're going to talk about here is content type. So content type is a header that you include in either your request or response that tells the person receiving or the party receiving that request or response. So in the case of like the request, it tells the server. In the case of the response, it's telling the client. It tells the person receiving that data the type of data that is in your body. So far, throughout the class, our bodies have always contained just like plain English text. But in practice, you can put a lot of different things in a body. You can put text. You could put like an image. Think like maybe you're uploading an image to a server. A way you might do that is you might put that image data in the body of your request. A PDF, maybe you want to upload a PDF, or like HTML. We just saw there a case where like we're sending back HTML and the response that the web browser was doing to sort of show that HTML in the browser. Like that's another type of data you might include, or JavaScript, like that we made a request to get that like fetch example.js JavaScript file. So each of those examples I just outlined has a different type of data. And the way that content types work, the way this header sort of works is the key, the name of the header is content-type in that train case we talked about last week. And the value of the header is this thing called a MIME type. Think of a MIME type like a file extension. It's a very similar kind of idea, where it's like a series of characters that identifies the kind of data you're sending. Importantly, the slight difference, though, between a file extension and a MIME type is a file extension is like the type of data in the file, and it's like in the name of the file. So there's like a name, like whatever dot extension. So there's like a place you can put that extension. With a request, you don't like, or a response, you don't really have like a file name. Like there's nothing like that. So you need like a place you can put that kind of information. And it just turns out that the way they decided to do it with HTTP is they're using this MIME type thing. This is sort of the format they use. They don't use an extension. Like it's not like a 3 or 4 character sort of like series of or 3 or 4 character like string. It's this MIME type thing tends to be formatted with a number of words that are sort of with slashes in between them. So great example. The MIME type for plain text, what we've been sending so far in all of our requests and responses, is text/plain. So if you make a request and include the header of content type text/plain, what that's going to mean is you're sending a request where the body contains just arbitrary like English text kind of thing. If you were to include the MIME type of image/PNG, that means, oh, I'm sending like a PNG image in my request, or I'm sending that back in my response. Or like text HTML is the MIME type for HTML. So if you were sending like HTML, or maybe actually going back over here, taking a look at the response headers here, hopefully. Should get it back. Or it won't. Okay, let's do this. Yeah, here we go. So this request here, I'm making a request to the server to get my fetch it example HTML. This is the one I went into here and I right clicked and I copied this as a curl. Sort of took this request, I brought it into Postman. This is that request. And you can see here in the response, the content type here of the body is text HTML. So that's sort of an example of a content type in action. Last thing I want to mention is the default content type. So like if you don't specify one, like what it sort of defaults to is this value application / octet stream. It's kind of a weird thing, but the reason why I'm mentioning it is just it's like a good thing to know that it's the default. And like to break down that meaning there, octet, like bytes have 8 bits in them, bytes being like what computers deal with and like storing things. So like octet, 8 bits in a byte. One word that often gets used for a byte is an octet, especially in like network contexts. So you can think of it as like a series of bytes with arbitrary meaning, a stream of octets. That's kind of why they call it that. Okay. Yeah, so very similar to a file extension is what a MIME type is. And there's a big, like there's a lot of them. So I here linked in the presentation a Wikipedia page on MIME types where it'll go kind of into it. But really the reason why I linked this is down here at the bottom. Oh, I thought there was more of a list. It must have updated the Wikipedia page. Well, here's a few at least. So there are MIME types for everything that there's like a file extension for, there's a corresponding MIME type. Yeah, nice. And so here's a list of a few of them. Give you sort of an idea of kind of what they look like. But you see a lot of them tend to start with application or a lot of, like audio or image. And the reason why they're structured that way is like they tend to be broken down where like you sort of have like a category at the beginning and then sort of like decreasing categories sort of all the way to the end. So they sort of like they could like sort them together to sort of how they fit together if you were to sort a list of them. But anyway, that's content type. So again, content type specifies the type of data in the body of a request or response. Except is very similar to content type, but except is only included in the request. And what except is it's a header you can specify in a request to tell the server what type of data you would like to receive in your response. So think of except as like you telling the server the content type you'd like to get back in your response. So normally when you make a request, you include a content type header to tell the server this is what I'm sending. And then you include an accept header to tell the server this is what I want to get back. So just like content type, the accept header uses a MIME type. And the default value is application octet stream. This is sort of how this would normally go. So something like I'd make a request that included content type of text plain with some plain text in my request body. And I might get back as a response something with a content type of text HTML with some HTML in the body. So the important thing to point out here is like the red lines up. So content type here, this is text plain text. And content type here, blue, text HTML is HTML. But then also, importantly, when I'm making my request, I'm saying, please send back HTML. And if the server is well-behaved, should be well-behaved, then its content type will match. It'll be corresponding. So like, if I say, send me back HTML, it will send me back HTML. Like, I say I want HTML, it gives me back HTML. Blush, go for it.
In case of content type, how does the server recognize or the client recognize like what sort of request or response is it? Like what specifies if it's asking for a particular MIME type in the request or the response?
So when you're making your request, content type specifies like the type of data in the request and accept specifies type of data in the response.
Oh, okay. So we're using both of them together. Yeah,
both of them together. So importantly, in your request, you would include both content type and accept. Now, like I should have also mentioned before I went into this, like all headers generally are optional. You can make a request without headers. That's totally fine. So like headers have default values. Like the application octet stream thing is like what they'll be set to if you don't specify them manually. But if you specify like content type, then that corresponds to the type of data in your request, if you include that header in your request. So it's like the type of data in the part of the the interaction you're going for. So if you include content type in your request, that's a type of data in your request body. If you include content type in your response, it's a type of data in your response body. So this is a header that can be in either location.
Gotcha.
But,
thank you.
Yeah. Then the other part. Oh yeah, go ahead.
No, sorry, please go ahead.
Oh, okay, cool. Yeah, so there's a bit of an interaction here where, like, I guess what you specify in accept should always line up with what you get back in content type in the response. So accept, importantly, this you would never do. Like accept is only a header you include in your request.
Okay, understood. Thank you.
Yep. Okay, yeah, here we go. So you might be like, okay, whatever, like, why is this important? Well, the reason why this is important is because there are endpoints that can give you back data in multiple formats. So one example here is maybe I've got an endpoint that can give me back data in either plain text or HTML. It can maybe format the same content differently. The way I can control what type of data I get back is by using that accept header, or this is sort of the standard way you would do that. Another situation that's very similar is, let's say you've got data where you can, like, you've got an endpoint that returns an image, but you want to like have the endpoint be able to return like a JPEG or a PNG, like two different types of images. You could handle that by your accept header sort of specifying a different MIME type. So you can make a request to that endpoint with a MIME type of like image/PNG, or you can make a request to that endpoint with like image/JPEG. And by controlling like the header you're sending, that accept header, you're controlling the content type and the corresponding response data you get back on the other end. So it's just sort of a way you can control the format of data you get back. And this is like a thing that's often really important. I will be honest, I'm not sure the demo is going to do here. And we're kind of, I'm going to kind of just keep rolling through this, and maybe we'll get back to this tomorrow if I can remember what that demo is supposed to be. So our next header here is authorization. So authorization is a header that you can specify. We've actually used it briefly before in our lockbox example. And it's a header that you normally use to specify information to identify who you are to a server. So let's sort of like go through a bit of a thought exercise here. Like, let's say you go visit like a some sort of like website. Like maybe let's say I think of like a good example here. Google.com. Keep it straightforward. Anyone can access Google.com. If you make a request to Google.com about get/request, so like that's the request I'm making, I send that to the server and I get back HTML in the response, like I can always, like that will always work because it's a public website. Anyone can access it. But there are parts of Google that are like private, that like not anyone can access, or importantly, you've got to log in to be able to access. So if I were to like click on Gmail right here, well, and sign in, like it's not going to let me access. If I go to gmail.com, like it won't let me get in there until I log in. Like I've got to log in first. And the reason, like the way that, or one potential way that could be implemented is if you make a request and you make that request without information identifying who you are, the server will just give you back some sort of 400 error, being like 400 starts with a 4. It means it was the client's, like the client's fault. They didn't include the proper information. So because it didn't include that information, like the server doesn't know who you are, so it doesn't know if you can access this page. Like the page is sort of protected. It's private. It's only accessible by a few folks. So this is sort of where the authorization header comes in. The authorization header is sort of the standardized way in an HTTP request that you identify who you are. And by identifying who you are, the server can figure out effectively what it can send to you, what information you are privy to. So the way the authorization header is structured is there's sort of two space-separated words you tend to specify. Now, importantly, earlier on in our class example with the lockbox thing, we just had one word in there, and that was just because I wanted to like just sort of get the gears turning. In general, you use two words to sort of specify to authorization the format by which the how you're going to tell the server like who you are. And the first word you specify is what's called the scheme. And the scheme is like how you're going to specify it, because there's like a lot of different ways you could say who you are. And then after that, the second parameter is like sort of the data that you sort of are giving to the server that should be interpreted with that scheme to like understand how you're authorized. So there's a number of different ways you can do this. The way that is probably the easiest to understand is what's called basic auth, or this using the scheme of basic. So what that is, oh, I'm realizing, Palash, you put a comment or a message in the chat. I didn't even see it. If the URL careers encode that xyz/fruit had an image at its end, we'd have to specify the accept header as image PNG. Yeah, that's so if like a browser is making a request to that, yeah, it would specify like accept image PNG, and that's like what you would tend to want to do. I'm being a little like coy on that because like you don't have to. You could specify like that data. You could omit the header, but if you omit the header, you're sort of not being like very prescriptive to what the server you want. Like what you're not being very prescriptive to the server about what you'd like to get back, and like it's sort of like the accept header allows you to sort of be very prescriptive and describe like this is exactly what I'd like to get back. So, but yes, you have the right idea. Like that's sort of where it would be used, where you would include that header to say like, give me this data back in the response, this type of data. Sorry, I missed that question. But going back over to authorization here. So the most basic sort of form of authorization is it's called basic auth, and you use the scheme of basic. So let me type this out here. I'm gonna make a new thing over here. I think actually, because I got the live share thing going, people can see, which is excellent. So I'm going to write out an authorization header. So I'm going to go authorization, and I have scheme, and then I have value. So if I have basic auth, what that means is the scheme is going to be the word basic. And you'll notice that the way this sort of header is structured, the first word is like the type of scheme, like the way you're going to be authorizing yourself. And the second word is like the parameter you want to specify and how it should be authorized. And with basic auth, the way it works is the second parameter ends up being some variant of something like a username : password. So in this sort of case, like what you're doing is you're saying, I'm making a request. And along with that request, I'm specifying a username and password that I'm sort of like sending along with my request as metadata. And what the server can do is it can take this data, this username and password, and it can like process it, and it can like use that to verify who you are, like what user you are. Maybe there's a big list of users that's got on the server side that's able to like look at that username and that password and verify and make sure everything all matches up. And if it does that and everything matches up, then maybe it will like give you back like a 200 with the data you want. But if it doesn't match up, then the server will give you back like a 401 unauthorized, or like a 403 forbidden, something like that. Importantly, it starts with a 4, so it means your client didn't specify the information it needed to do to access this data. So that's kind of the gist of the authorization header, what it allows you to do. It allows you to access protected resources. It allows you to make requests to the server where not every, like to access non-public things. There's one other sort of scheme I want to talk about. So basic is sort of the easiest to wrap your head around, but the one that we're going to be using much more often is what's called bearer. So importantly, for the bearer auth scheme, the difference is the first word instead of being basic is bearer. And what you do, what bearer auth takes is what's called a token. So this is a bit of a different way of approaching authorizing yourself. So with the basic auth scheme, we put about a username and password. So just like, that's pretty straightforward. Everyone knows what a username and password is. You've like logged into stuff before online. So like, that's a thing where you can specify that information. It's as if you're like logging in when you're accessing that, making that request. But the bearer auth header uses this thing called a token, which is a little bit different. So a token is a pre-generated identifier that's created for you by the people that run the server. So think of it like this. Think about like I have like a big list of a bunch of random strings, like passwords almost, like random letter and number passwords. And when you want to access data, what I'll do is I will go, like me being like the person who's running the server, I'll have my big list of passwords, and I will add in, like you say to me, like, I'd like to access your data. So you would say, okay. And you'd say, I am person like A, my name's Ryan. So what I would do is on my big list, I'd be like, okay, so I'm going to like, for Ryan, I'm going to generate a new one of these like password strings, these token strings, and generate this like random letter and number string for you. And I give this to you. I'd say, okay, here's your token. And this token is sort of like a password you can use to access data on the server. So then whenever you want to make a request to the server, you can include this authorization header and then include this bearer space in your token, this like random letter and number sort of thing in there. And what I'll do is, as the server owner, whenever I receive a request that's got this authorization header of authorization, bearer, and then this token, I'll take this token and I'll look it up in my big table. And because I've got like two columns in there, one of my columns is like the person's name, the other one is like the token. I can be like, okay, let me find a row that's got a matching token. And once I find that, I know who it's associated with, like the person's name. So it's like a bit of a different approach and like the basic sort of username and password, basic authorization and password kind of approach, but it accomplishes the same kind of idea where this token value is like a password that I can include in my request that will allow me to identify who is making that request. Does that make sense? Any questions on that? In general, this token idea is one that we're going to run into quite a bit for the rest of careers in code. Palash, go for it.
What would be a popular example of websites that use either basic or bearer?
Yeah, so almost every website that you're going to log into these days that is somewhat modern will use a token. I'm trying to think of one offhand that like everyone knows that I could like show you actually. Let's see. The reason why I'm thinking is because I'm trying to think of one that like I can like show you that will like totally work. Like I can show you the header in the web browser. It'll be like everything will be good there. Let's see. Let's go with GitHub actually. I think GitHub might. Oops. All right, so what I did here, just to maybe walk you through this, is I opened up DevTools and I went to the network panel. So remember I said the network panel you can use to see every request a website's making. So I'm going to go into here and I'm going to see if I can find an authorization header in here somewhere. Nah, they're going to use cookies. Okay. This may not be a great example. Let's see. Another example I can think of here. Let me do this. Let me get back to you on this tomorrow. I think this is good though. I want to show you like an example of this working. It's more just I can't think of something off the top of my head that would be easy to demo. So let me think about it a little bit overnight, and I'll first thing tomorrow, or like first thing class tomorrow, I'll sort of do a demo of this to sort of show this in actual use. But in practice, what you'll see is you'll see like a request a website's making, and it'll include that header authorization bearer, like the token. And it's kind of cool because you can see that being sent along, and then in the response you get back the data. And if you try to recreate that request without that header, it's just going to give you like a 400 of some sort. You can kind of I think it'll help that make more sense, but I just don't have a good demo pre-prepared here.
No problem. Thank you.
Yep. Yeah. Oh, well, I kind of have this here too, I guess. So like this is kind of what it looks like if it's successful. You get sort of the client making requests to the server, you get back a 200 if you've got like a valid token in there. But if you have the header missing or you've got like a bad token, you get back something like a 401. Yeah, and I guess I also want to call out that if you're using tokens for authorization, like all the stuff that I'm talking about with headers is like a recommendation. People, and this is going to be another theme for like the rest of the week. HTTP is a specification. It's a protocol that people should follow, but in many cases they don't. And this is another reason why I had to think a bit there, because authorization is where you should put a token. A lot of people just don't put it there. GitHub didn't put it there. But they use a token. They just didn't put it there. So that's kind of what's a bit tricky here, where like you're going to find that a lot of services, well, you'll need to use the token, but they'll be like, oh, you put it somewhere else. So you put in a query string parameter, you put in another header, maybe a header called like my token header, or what, like it ends up being like the most inconsistent stuff often. But the place that it should go is in the authorization header. So yeah, I'll have a better demo for that tomorrow though. Okay, so the next header here, location. Have you noticed that in general, we've talked about 200 class response codes, 400s and 500s. We haven't talked about 100s and 300s. Now, I know that like 10 minutes or 20 minutes ago, I brought up like 304 for a caching thing, but putting that aside, like we haven't talked about 300s at all. And the reason why we haven't talked about 300s is because they're used a lot less than like 200s, 400s, and 500s, but they do have an important use. And the location header, it sort of comes into play into where they are used. So 301s and 302s, and a few other the 300s, but those are the ones that I think are most important to know, do what are called a redirect. And I think it's so imagine you have like you're like in like a library, and you've got a bunch of books on the bookshelf, and they're all sort of sorted in an exact sort of way, and you know where everything is. And whenever you want to go, like you come into the library and you're like, oh, I want to read my book. You go to the bookshelf, you find your book at that specific location, you pull your book out, and you like bring it over to the table, you like open it up, you sit down, and you start reading it. And like you really know where that book is. You like always know where you're going to go to it. And like when you're done, you go over, you put it back, and you leave, and you come back the next time, you find it there, you pull it out, you start reading it. Like you always know where to go to find your book. And wouldn't it like really make you angry if like you come into the library and the whole library decided they want to reorganize it? Like they want to be like, things change location, like things are in new places. And it's like, I don't know where my book is anymore. So this is a problem, because if you think of like you going into the library to find your book as like a computer, sort of like making a request to a specific location to like try to find the thing, computers are kind of dumb, like just being straight up. Like they really just, they kind of do what they're told, and that's about it. And if you tell a computer to go make a request to a location, it's going to like make a request to that location. It's not like, and even if you like change how things work, like it's just always going to request that exact same location. So what a redirect is a redirect is a way where when you make a request to an endpoint, the server can actually return back a response that says, actually, there's nothing here, but this data moved somewhere else. So like in that sort of case of the library like example I gave, if you walk in and you're like looking for the thing, and it's like, wait a second, it changed. Think of like the redirect, like maybe having like a little like marker on the bookshelf. It's like, hey, were you looking for this thing? Actually, that's over there in that other section over there. Go look over there instead. So what you do is you like come in, you like go to where you were looking. You're like, oh, I see that redirect. And then that tells you where you need to go find the book again. So what that means is if you do this, go through this redirect workflow, there's actually it's a bit more complicated than just a single request. So like you might make a request like to /first. Maybe that's like where your data is located. Like, oh, that's always where I go to get my book. You make a request to /first. And what you get back is a 301. And in the response for the 301, you've got a header that says that's the location header that says, actually, your stuff's now located at this second URL. And that second URL is now like the client will be like, oh, okay, that's where it is now. So it'll like terminate its connection and make another request and be like, oh, okay. So instead to get my thing, I'm going to make a request to /second. And it'll make a request to /second, it gets back at 200. And then what it'll show you is like, hello. So what's cool is you can make a request to /first. And if the server sends you back a redirect, what you'll get back is like this stuff. Like you'll get back the stuff for the new location. So what it means is as someone who like writes a server or sort of manages a server, you can change where things are located and maintain backwards compatibility. Like you can sort of old clients that are making requests can still make requests to those old locations and still get back the correct data. So that's kind of what the idea behind a redirect. Any thoughts on that? Any questions on that before I continue? Tara.
Who controls how long it stays up there is indefinitely. Like you can come back however later in life and be like, oh, I'm gonna go use what I normally use. And
Good
it's still
question. So that's the difference between a 301 and a 302. So a 301 is a 301 moves permanently. So what that means is the redirect happened, and you can just sort of think of that old, like the /first is like data will never be there again. So what's cool about a 301 is actually the client, if they do things in a standards compliant way, will store that locally. At any time the client tries to make a request to /first in the future, it won't even reach out to the server. It'll just be like, oh, actually, I know that moved. Like, I just know that. I remember. It's as if like you go into the library and you don't have to go to the first book location anymore because you now know the new organization scheme. So you can just like go directly to the second one because you just know like, oh yeah, it's in the new location now. So that's what a 301 does. A 302 is a 302 found. And what that means is it's a temporary redirect. And there's a few other, like I think 307 is also a redirect. There's a few other ones too. But like those are the two most important ones. And the 302 means the temporary redirect. So it won't cache it locally. The client will always make a redirect or always make the request to like /first, and will always end up getting back to 302. And then like, so it'll go through this dance every single request. Where with a 301, it'll go through this dance for the first request, and then for the second request, it'll just do the second part because it's able to cache this locally. Does that make sense? Cool. Yeah, so I will say that the reason why I'm bringing this up is redirects come up pretty often, but usually they come up in more of the context of like building websites. So what you might do is if you make let's say you have an HTML file and you have like a file called like test.html, or no, let's actually do something else. Let's say like it's index.html, and you have like your application's like it's like you've got like one page index.html, and then you've got like another page. Maybe it's like, I don't know, like about me.html. So you've got like these two pages and you've got like links between them. And then you decide, actually, I want to like merge those two pages together. I don't need the two pages. They're both kind of small. I'm just going to like put it all together in like one big page. But you've had your website out live for like years and years and years. And like there are people, like maybe you've got like a business card. On your business card, it's like mywebsite.com/about. And you're like, oh, but if I like combine this together, like that /about link isn't going to work anymore. Like you really want to maintain that link functionality. But you don't want to like have a duplicate of your page. Like you just want one copy of it. So this is where like you'd use a redirect. So you can have the server send you back a redirect for that like /about page. And then it'll redirect just back to your index.html and everything is great. So like your link still works, but you've got one page and everything's great. So that's like a concrete example of where you'll see redirects. You typically won't see redirects with like an API endpoint. You won't see redirects in situations where like you're like making a request to the server to get like dynamic data. You're like asking the server like a question, like that, more that kind of thing. You're going to see it more with like static data like HTML, images, JavaScript, things like that. Okay. Next, the host header. So the host header is one that is included always in every request by a web browser. And in general, it's a header that you should always include when you make requests. We haven't so far. And that's kind of like an anti-pattern. Like you really should always include it when you make a request. What a host header does, though, is a little bit weird. Like it's something that like is kind of unusual. And I'm going to walk you through a bit of a scenario to explain why it's important. So, but to maybe like spell out what it does first, a host header will include in the request the domain name that you are making a request to. So what your web browser does behind the scenes is something kind of like this. It might do like connect to example.com on like port 80, and it might send a request like get / HTTP 1.1, and then include a header, host example.com. But like probably what you're thinking is that seems super duplicative. Like you're connecting to here and you're including it here again. Like, why do you have to include it twice? Doesn't the server already know like what you're connecting to? Like, what's the deal here? And you're right, it is kind of duplicative, but it's actually really important. And the reason why it's really important is because how the actual like network request is working behind the scenes. So remember, like we have the DNS thing. So when you have a host name, that sort of gets like you look up that name in the table and get the IP address for like where that server is located on the internet. And then once you get that IP address, like that's what you make the request to. So like you don't actually make it like you can like type in like a domain name and make a request to it like with your tool Netcat or Postman or whatever. But like behind the scenes, the computer is actually taking that DNS name, resolving it to an IP address, and then making a network request to that IP address. So like it's a little semantic difference, but this is like actually really important in this situation because the actual host name never makes it to the server. So you're converting that host name to that IP address on your client. You're never actually sending that host name to the server ever. But like, again, you might be wondering, like, why is that important? Like the server's receiving a request. Why does it matter necessarily like the host name that was put in? Like if you had maybe example.com and that resolved this IP address, and example.org and that resolved this IP address, like, why does it matter? I mean, they're both going to the same IP address. Like, what's the big deal? Well, the problem is if you have two different clients that are making requests on like different host names to the same port, the server can't tell them apart. If your server is serving multiple websites, it needs to know, oh, if you're making a request from like this host, it needs to send you back one set of files. If it's making a request on this host, it needs to send you back a different set of files. So that's why the host header exists, because at the server's end, it doesn't know where you're making that request to, because the DNS lookup's happening all on the client side. So it's just receiving requests coming in from like arbitrary IP addresses. And it can't distinguish them. So that host header is how you distinguish it, how the server is able to figure out which requests are coming from which host names, which DNS names. Why am I mentioning this? Well, because this is it's again, one of these things where like it's an important header to include in your request. And if you don't include it and your server is hosting multiple websites, and just a hint, like basically every server is hosting multiple websites in like the way things are set up these days. Just sort of like that's the way it makes sense to do it from like a cost standpoint. It's just economical to like share servers. Because you're doing that, if you don't include that host header, your server is just going to be like, yeah, I don't know what to send you. Like it's like you forgot a very key part of your request. Like I don't know which website you want me to send you back. So it'd give you back some sort of 400 and just be like, you got to give me more detail here. I can't answer your request. So I'm mentioning it because it's a really important header to include. And if you don't include it, in many situations, you're just going to get back a 400. So like the moral here is like, it's a header you should always include in every request you make. And we haven't included it so far because my server, the careers.xyz server, I'm just running one website on there. So I'm able to just be like, every request that comes in, I'm sending back data for careers.xyz. But like, that's like unusual for these, like the way things are running these days. Like you'll have servers that run multiple websites. So you need to sort of disambiguate that traffic. Cool. Thoughts on that? Any questions? Okay, I'm going to keep going here. So our last group of headers we're going to talk about are for something called cores. Now, I'm going to do a bit of an abbreviated thing on cores. I don't know how, we're going to see. If it becomes a problem, I might end up like rerunning through this again later on in the week. But cores is this thing that every web developer absolutely hates. Like if you go up to like Max and you say, hey Max, what do you think about cores? He's probably gonna like say some not so nice words. Like ask Nathan, he'll also say the same thing. Every developer who has done like a serious amount of web development just does not like cores. It is a technology that secures the browser. It's a browser security feature. Now, I mention this because it only applies in a web browser. If you make requests with curl, with Postman, it's not going to be a problem. You're never going to run into cores issues. You're only going to run into cores issues in a web browser, in Chrome and Safari and Firefox with a tool like Fetch. It's just sort of like it's a browser feature. And web developers hate it. So what cores, like if you've ever seen an error that looks kind of like this is a cores problem. In particular, the reason, like the thing that like I'm looking at that like pokes out at me that's like cores, that like it's like the blinking sign that says cores, is if you see something that says like a no access control allow origin header, that like prefix, like access control allow something, like that phrase is synonymous with cores. And what you will see is sometimes when you try to make a request in a web browser, you'll see an error that shows up like this. It's like this red arrow in your console. It's like, I can't make a request to this URL. And also what'll end up happening is your your fetch call, you'll never actually get like an event that comes through. Like it just won't, like your fetch won't work. You won't ever get the response to come back. And the reason why is because there's this really important thing on the web, what's called a same origin request and a cross origin request. So this is getting in the weeds a bit, but the reason, like as I should also say before I get too much into it, so the reason why I'm going through all this, the reason why I'm talking about cores is because there are some really important headers in requests that control this cores thing. And if you don't specify these headers properly, you just won't be able to make requests to certain endpoints. And this is why web developers often get so frustrated with cores, because it's very tricky to configure. And if you get it wrong, you just can't make requests in a web browser. And it's the kind of thing where like you try to make a request, it doesn't work. And you're like, okay, why doesn't this work? And you like change it around a little bit. You're like, okay, let me try this header. And it's like, oh, wait a second. Nope, still doesn't work. Okay, let me try this header. And you have to go through like 5 or 6 iterations. And it's like every time it doesn't quite work. It's like something's a little wrong. You have to tweak it a bit. And it's because the reason why it's so complicated is because all these rules about like how you can make requests in a web browser and like what works and what doesn't. So I'm going to give you sort of a high level overview of this. I'm not going to get into the weeds. I'm going to give you enough so you sort of maybe know the words you have to start to look up online to like fix these sort of problems. But importantly, like cores, I could teach like a whole class on it, like a whole day on cores. I could probably even teach multiple days on cores. It's like complicated. It's got lots of rules, lots of sort of gating things around like where you can make requests, where you can't make requests. But the sort of namesake, of course, cross-origin resource sharing, like where that comes from, is this idea of a same origin versus a cross-origin request. And this is sort of the most important concept in CORS. There are two types of requests in a browser: same origin and cross-origin. A same origin request means the domain name in your URL bar and the domain name you're making a request to match. So that's something like, if I'm on careersencode.xyz and I make a request to careersencode.xyz/fruit, then that's the same origin request. A cross-origin request is different. So a cross-origin request is if maybe you were on careersencode.xyz, but you made a request to like example.com. So importantly, this and this don't line up. They're different. That's kind of the difference. Like a same origin request is you're making it to like the same thing. Cross-origin requests are different. And the rule is, in general, in a web browser, JavaScript can only make requests to endpoints in the same origin. So if you are on like domain.a.com and you try to make a fetch request like domain.b.com, it's not going to work by default. And this is just how web browsers work. So let me sort of prove this to you. If I go to like careersincode.org, so something like, or even better, I'll go to like google.com, something completely unrelated. And then I'm going to fetch, I'm going to do a fetch call in here. I'm going to do a fetch. I'm going to fetch careersencode.xyz/fruit. So like, this is like just like we did before, making a fetch call in the web browser. It's not going to work. I'm actually going to do it from careersencode.org because it's going to be a better failure mode here. Yeah. Not going to work. Oh, you know what? Yeah, I gotta do something on HTTP. Example.com. There we go. No, I want HTTP, not HTTPS. Okay. Okay, what's something HTTP can do? Okay, I'll do it this way. I'll do yeah, there. HTTP. You can tell I'm at the end of the lesson and I'm tired when I can't properly type and do the thing that I know how to do and I want to show you. I apologize, folks. Okay, so I'm on a domain here. I'm on example.com. I'm trying to make a request to careersencode.org. Those are different origins. They don't line up, and I get an error. But if I make a request to example.com, it'll get an error. It totally works. And if I go over to my network panel here, I can see got a 200. That worked. It was successful. So this is sort of this idea of like same origin and cross origin. And I think if there's one thing you take away from this core stuff, it's that you cannot make a cross origin request by default. You have to stay same origin unless you want to get into CORS. So what CORS lets you do is configure the ability to make cross-origin requests for a server to sort of opt in to allowing you to do that. There's a question, though, that's worth asking, which is like, why? Why is this like, why does CORS even exist? Like, why is the problem? So there's a lot of reasons. One, though, is security. So imagine you are on like Gmail or something like that, some like web tool, and you make a request to the server to like delete an email message. So you're like in your thing and you're like, okay, so I'm gonna like click a button, like delete my message. And what's going on there is like the web application is like making a request to the server to be like, delete this message. And the server comes back and is like, okay, cool, I deleted the message. Great. So no problem. Like that's just how the application works, making requests, getting back responses. This is fine. But where things get a bit more tricky, what happens if something that is not gmail.com makes that request? For example, some malicious website like hackers.us makes that request. Like if you go to like hackers.us, that website could make a request like fetch gmail.com / like it could make this request. And if it does, Gmail servers would have no way of knowing like which application made that request. Like it could be gmail.com or it could be hackers.us. Like the request is coming from your computer. So the server just would honor it. It would be like, oh, okay, I guess gmail.com just is like us deleting a message. But of course, if you went to hackers.us and it deletes your message, you'd be like, what the heck? You'd be kind of angry. It's like, it's deleted my thing. What's going on? It's not good. So this sort of attack has a name. This like security vulnerability has a name. It's called a cross-site request forgery. But because CORS exists, this can't happen. Like this is a cool thing. Like CORS protects you from this. This is like a hard problem to solve. But like, again, like I mentioned it before, like sometimes you want this. Like sometimes you want to make cross-origin requests. Like in certain cases, it's important. And like web APIs are a great example. So maybe I've got like a service that I'm hosting on like myapp.com or something, and I want to allow people on like to make requests to it. Or like maybe a more concrete example. Let's say I'm like Twitter. I'm running like twitter.com. And I have requests on that website that like I want to allow people to make like third-party Twitter clients, like make their own web applications that they can chat to Twitter and make requests to. So like they could on some user's behalf like create a tweet for them or something, because that's what the application does. Like it's a tool you can use to do all that stuff. So like that's a situation where you want to allow cross-origin requests. So it's like there's clearly situations where like both behaviors are desired, where like you don't want to allow people to make certain requests, but in certain cases you sort of want to permissively open up that like filter. You want to allow people to make requests sometimes. And that's what CORS lets you do. It sort of lets you control how you can make those cross-origin requests. So like mechanically how this happens is whenever you make a cross-origin request in a web browser, it actually will do what's called making a pre-flight request beforehand. So this is like a request before the request. It makes a request to the server with a special method, options. This is a new method we haven't talked about. It's like only for CORS. It's like a special CORS thing. It'll make a request with the method of options, but it'll have everything else in the request the same. And what the server can do is it can look at that request and can be like, is this a request that would I like to handle cross-origin requests from this client? And if the answer is yes, it returns a 200. If the answer is no, it returns a 400. So you're basically just like the browser is asking the server like, am I good to send you stuff? And the server can be like yes or no. And if the server says yes, if it sends back a 200, then the browser will follow up with that request with the actual request it needs to send. So like in the Twitter example, if you have your application, you can make a request to like Twitter, and Twitter can be like, oh yeah, I want to let you in. You send the pre-flight options request. I think I have so you can send your cross-origin request to the server. The server can decide if it wants to receive it, and it can send back a 200. And if it's successful, then you send your actual request. The browser's like, oh, okay, I can send this. I'm good. But in the other case, if you're like, oh, wait a second, this should really be like 400. But so you send that back, and it's like, oh, that didn't work. Then it just stops. Like, you're done. Like, that's it. Like, the browser just won't send the request. So something like Gmail that they don't want to allow people to just make arbitrary requests to Gmail. They can like lock down all their core settings and not allow people to make requests from arbitrary browser origins. And then the only person who can make requests are those on the same origin, those that are on gmail.com. In other words, Gmail's own first-party application. But in the Twitter case, they can open it up, they can allow anyone to, and they can maybe do things like require you to include a token, like an authorization token, to make sure you're who you say you are when you make that request. And so that's how they can verify, like, okay, they'll allow you to accept the request, but we also need you to include a token to make sure you are who you are. So really, though, like, that's sort of cores in like a 10,000 foot nutshell view. Really where I wanted to leave you though with cores is complicated. It's not something I can go through quickly and like explain to you how all the intricacies of how it works. But I think if you're able to follow along with what I just said, and if you weren't, like, you're able to watch the recording later, like, that's really sort of the core part, this idea of cross-origin requests, same origin requests, and being different things, and that cross-origin requests are like a protected, difficult thing that like should be hard, and that you need to sort of get permission from the server before you make it. But like, this is just it's a hard thing to wrap your head around. It's complicated, it's tricky, and you're going to run into problems with cores, and you're going to hate cores. Like, I'm just going to say it right now. You're going to hate cores. Like, every web developer hates cores. I posted a link at the very end here because last cohort, I had someone bring this up, and it was a really good article, I thought. Sort of goes through cores, maybe with a different way of explaining it. So if that's helpful for you, there's that. Yeah, so that is everything I wanted to get through today. I'm kind of feeling like a zombie right now. And if I'm feeling like a zombie, you all must really be feeling like zombies right now. So that's where I'm going to leave things. I think probably at the beginning of next class, we might do a quick little run through of all the stuff just to maybe review it. But I think that's about it for today. Any questions? I realize that is quite the prompt, but any questions? Okay, that's fine. Have a good evening. Get some sleep. See you tomorrow. Bye.